Hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. I hope everyone's having a wonderful day. Henry, Emerus, Nick, thank you guys so much for coming in. And anyone who might be lurking in chat, hey, thanks for being here. Emerus, thank you so much for the 19-month subscription. Really appreciate that. Um, it wasn't exactly a phase. So the issue was, I've mentioned this before, but when I was in high school, I swam a lot. My hair was completely, always completely covered in chlorine, which meant it was always pretty much dead. And anytime I ran a towel through my hair, it would just spike up like that. So that was just what my hair looked like after swimming. And I swam every day. So, I would just dry my hair like that. And then I'd try to comb it out afterwards because that was the only way I could do it. It has not been that way for years. But there was a time in my life where almost every day my hair would look like that for, maybe a few minutes or maybe up to an hour as my hair was drying. Yes, and the hair was actually quite blonde, again, because it was dead because of the chlorine. It was such a weird, it was so hard doing high school during that time. It was kind of weird. Anyway, the reason it's an emote is because people wanted it to be an emote. So it's okay, there you go. That's our emote that has my face on it because for some reason people like emotes with people's face on it. Anyway, here's what we're doing today, guys. We're going to start with a bit of algorithm archive work. Why? Because I've been putting it off for a while. Way longer than I should have. Because I ran into a bug with Julia that has it has royally screwed me up. I've been working on this thing for the past 4 days, and I genuinely have no idea how to progress with that. So algorithm archive work at least for, an hour or something like that. And then we're going to try to fix what is broken in Julia. Look, I really don't think we're going to get anywhere with it, but I'm going to try, and we're going to see what we can do. So algorithm archive first, github.com, algorithm archivist, sure. And then we're going to go to pull requests. There were a few of these that I can just go ahead and start working on. So for example, this one is one that we can probably go ahead and merge in. Some of these might have already been reviewed, just not by people in the algorithm archive community. I have to look at the citation.cff file. Fixes in path. This is also something that we can probably merge in. And there's just a lot of work that happened in the past few days that I have not fully looked at. So we're going to start by looking through all of that. Again, Emerus actually started looking at some of the old PRs, really old PRs from 3 years ago that still need to be updated. So we'll look at that as well. So first, error and threshold for approximate counting. Let me take a look here. This should be conversation. The printed error threshold values in all implementations of the approximate counting algorithm seems to be off. Currently, the first two test cases, 1% error is printed when we are actually using 10%. In the last case, we print 10%. And use 20%. Right. What's your scons branch name? Doing the dev container test? Okay. So I think this one could just be right off merged in. Yeah, I don't see any problem with this. This is just me being bad at typoing, or me being bad at typing when I was doing the Julia implementation, which seems right. Okay. So review changes, approve. Yeah, this is a typo on my part. All right, let's go ahead and submit review and get that guy merged in. It doesn't change any of the line numbers or anything like that, so I see no reason why we can't just go ahead and get that guy in. Okay, that's one PR down. Citation.cff file. Okay. So this one is going to take some discussion, so I'm going to move on to the next one first, and we're going to come back to this one. So fixes in path that make dealing, emoji code, and factory usable. What is this actually doing? This is for... this is for the dev container. Maybe it's best if Nick looks at this, because Nick probably knows more than I do about this. Yeah, so we'll leave that one for now, and we'll move on to the citation.cff file. Okay, there's actually something else I promised to do for Emerus, although I'm trying to remember what it was. It was a mention about... Oh gosh, there was something. It was a mention of the algorithm archive 2 days ago, and I said I'd do it on stream, but I didn't. And now I don't remember what it was. It had to do with one of the old branches. Oh, right. It was, I think it was the Barnsley Fern or Huffman encoding. It was one that I put up. Let me just look for all my PRs. It was this one right here. That's the one I need to do. Okay. So let's take a look at citation.cff and the Huffman one. And these are the two that we're going to be looking at. Okay. So citation.cff file. First of all, I'm incredibly excited for this. What is it? Good question. Essentially, if somebody wants to cite the algorithm archive, they need to have, some sort of way to do the citation, and a citation.cff file allows for people to do that. It's not a full, peer-reviewed piece of work, it's not like the Journal of Open Source Education or anything like that, but it's a step in that direction, and I think it's quite nice for that. Let me take a look at the files changed. Oh, okay. Let's see. Now I do know that some of these people do actually have ORCIDs, and this is actually a lot of work now that I look at it. Let me see if I can find Jeremy's ORCID ID or not. I cited your FFT page in a journal paper. Oh, okay. In that case, we probably should have this citation.cff file available somewhere. Is it in your fork? Okay. So here's what we're going to do. We're going to do, we are going to do, what are we going to do? Let's just go ahead and look up, I know this guy. Here we are. Postdoctoral researcher. Right. Yeah. This is what I expected. He's actually got a decent number of citations. I was surprised by that. I mean, I'm not. It's way higher than I thought it was. Okay. So let's see. What am I gonna do? What I'm looking for is his ORCID ID. Here, ORCID. Let's see what we can find. I might not be able to find it here, but we might be able to link him. Yeah, okay. Let's just go ahead and mention that here, here, and just say, okay, so we do have some issues here. For example, Nicole, for example, did not actually want to be notified as part of this project. So I want to mention that, let's see. Are there plans on adding more data structures to the algorithm archive, linked lists, and hash map? Yeah, as the algorithms demand them, I plan to add them in. It's just, again, I'm so slow with the algorithm, like the chapter implementations and stuff like that, which is another thing that I think we'll start doing next week. We'll start doing more algorithm chapter reviews as well. It was something that was brought up, I think, today by Amaras, earlier today, and totally right. I should definitely spend more time going through and looking at older PRs and getting those things merged. So, all right, let's just go here. So my big issue with the citation.cff file is that it, like the contributors.md file, I think should be opt-in. And I'm not sure if we can just say that all the people who are opting in to the contributors.md file should also be opting in for the citation.cff file. So I'm just going to add a start review. Hey Cosmic, how are you? Oh, did you put your E down in the Discord or not? I know you're the E guy. I knew that. You're one of the two people in the Discord that have the first to E. What is it called? Role or whatever. I think Amaras is the only other person who has that. So let's go ahead and just start the review here. I'm going to go down here and say, I guess I can grab these 3 lines and say at GA. Okay, so add a review comment. Good. name, family name. Wait, how does this work? So it just knows that name, family name. Wait, how does this work? Nick did the E as well before. Cosmic did today. Ooh, okay then. Let's go ahead and fix that one. First to E in there. 1 second. So 3 people now have the first to E badge. Slowly but surely growing bigger and bigger. Okay. I am quite curious as to how this works. Like, for example, these guys in here, we have family names, given names. How do we... I'm going to ask a simple question here. How do we organize it? You're too competitive about, like, randomly pressing E after I click the go live button? I mean, that's quite... I mean, I guess everyone has a Simuleos notify tag, so I guess it's pretty easy to do, but... let's add the review there. Okay, overall, I think that's fine. Right. Oh, there was another thing I have to do, which is update the Euler method stuff. Let me go to issues, and I'm just going to go ahead and create that issue now. Bug report, chapter request. I think it's more of a bug report than anything else. And let's just say, okay, fine. Description, notation, and Taylor expansion for Euler method and images are incorrectly labeled. All right, I'm just writing this down because otherwise I'm going to forget. We don't need steps to reproduce in this case. Yeah, I don't think we need any of this. So environment. Yeah, okay, we're good to go. Perfect. Here. Ooh, additional context, whatever. Notational error note. There was a private communication on Discord about this. Okay, I'm just mentioning that, and then just say up here, Euler method. Okay, I'm just mentioning this here so that I have it down, and it'll be something that we can look at later. What do we have here? I'm too competitive, must enhance myself with the complex machinery. By the way, XHSZ, thank you so much for following, really appreciate it. Can you give me the Git instructions on Discord? I don't want to mess it up. Right, 1 sec. First, show me your branch. Whatever. I haven't been there so long, I don't even remember what the algorithm archive is about. Yeah, I'll introduce it in just a second. Git merge, origin master. Oh wait, it's a fork. You'll need to update your fork from upstream. Updated. Okay, so let's just go ahead and mention this, put it in the review. Okay, so for those of you guys who may be just coming in, maybe don't remember what the algorithm archive is about, let me just go to the algorithmarchive.org. This is essentially a textbook on algorithms with the intention of having each algorithm implemented in various different languages. So for example, here's Monte Carlo, and you can switch which language up here, and it will switch all the code blocks to match whatever language you're trying to read from. No, this has some challenges in actually writing code that works across multiple languages. So even though we try to make the code as, like, you know, idiomatically Python or idiomatically C++ or whatever as possible, we do sometimes run into issues where in order to put it into the book, we have to kind of like change how we define certain things. Like, so a lot of times the Julia code is not as Julia-like as you might expect from a Julia textbook, right? But it's meant to be easy to read. The whole point is to use the language as a way to better understand the algorithm. And there's a lot of things going on right now. For example, Nick and Amaras and Stormavice and a bunch of different people are all working on like different aspects that are all kind of related to, like, validation, making sure all the algorithms are correct. You know, for example, Nick has a dev container that was just recently merged in that allows for us to kind of creating a better environment. Amaras created a sconce PR, which allows for us to better build all the algorithms together. There's just a lot of things like this that are all going on, and it's really quite cool to see everything come to life. Okay, so let's keep going here. Oh no, here. Nope. I need to go back to pull requests and go to the one I was just on, which is citation.cff. Okay, let me read through the discussion here. I read through it before, but I've kind of forgotten exactly what the latest bit of it was. Here, I think we're close to a first version, so I'm drafting it. I'll clean up with all the commits into one once all the reviewing is done, and don't hesitate to run me. So I've got a general question about this, which is why I didn't know how to do it to begin with. So here the message, if you use this software, please cite it using the metadata from this file. I think maybe we should change this message to something else. Suggestion. Come on. Suggestion. I can type, I promise. Here it is. Enter message. If you use this, how do I do this? If you use this resource, I think I should say resource, please cite it using the metadata from this file. I think that'll be fine. Add review comment. Arcane Algorithm Archive, date release 2017, URL algorithmarchive.org, repository. Yep, sounds good. License URL, keywords, algorithm, language agnostic. Collection of algorithms, open research, data structures, collection of data structures. Sure, that all seems fine. Type software. Are there different types available here? All right, add review comment there. Okay, so my next thing is this. So, let's see. This essentially counts as a release. Wait. Okay, add a review comment here. I'm just asking a bunch of like basic questions that I don't know the answer to. What do we have here? Go to your fork. It sounds cool, actually useful. Meanwhile, I'm just writing pathfinding bot in platform-like environment. Honestly, that sounds way cooler than... So a while ago, like 2 years ago or whatever, when you were somewhat more active on the Twitch stream, I remembered that you were working on fundamentally different stuff. It sounds like this project that you're working on right now is a step up, really, from the stuff that you were working on a few years ago. It's quite nice to see that progression, you know? Do you mind if I push a commit to your branch? Please do if you need to. Hey, Gibbous, how are you? My sleep schedule is weird, so I'm about to go to sleep. But today I successfully failed to clone a GitHub repo. Wow. That sounds like my last 3 days doing bug hunting for this Julia bug. All I've had to do is convert an int64 to an int32, and I failed to do it for the past 3 days, and I can't figure out how to fix it. It's a pain. We're going to talk about that later. Sign up for CodeSpace here to make your life with these reviews easier. What is that? What site was that Monte Carlo thing? Joined just as you closed. Yeah, I'll give it to you in just a second. It's a site that we're actually working on right now. It's the Arcane Algorithm Archive. So let's go here. I'm an idiot. Let me try that again. I missed the S. Yep. Blazing Fast Cloud Developer Environments. Wait, what is this? Wait, Nick. So sign up for CodeSpace here to make your life with these reviews easier. How does this work? Wait, okay. First, the Algorithm Archive. Let's go here to Algorithm Archive here. Yank paste. So here's the book that we're working on right now. Mine's 3 days from a data type. Oh yeah. We'll get into it in just a second. That's why the stream says, well, it's broken. We're going to talk about exactly why it's broken in like, I don't know, like 30 minutes, an hour. Just once I feel, once I get some sort of wind under my sail from working on the Algorithm Archive PRs. Citation.cff. Okay. Let's see. So this effectively works as a release. I deploy a full dev environment for each review. Right. Oh, cool. Thanks. Wait, so you deploy a full dev environment for each review. Oh, wait. So you can put that into this GitHub space so we can just... Wait. No, I'm not actually sure what the GitHub space is. I'm so sorry. If you could like explain it one step at a time. A-star algorithm's just not in there because I haven't... The problem is my focus is usually on like more like numerical methods, like computational science type of algorithms, and a lot of that doesn't have so much in the way of like graph traversal and stuff because it's difficult to do that kind of stuff in parallel. As such, I haven't really had a need to go into A-star algorithms and stuff like that, which is why it's not particularly, it's not on the top of my list of algorithms to go into. Let's go here, citation.cff. Anything else here that we might want to say? Yeah, the last thing I want to say is the following. Okay, so overall, this is a really good step. Overall, let's see. Let's see, I'm a bit weary to put everyone in the citation file. Let's see if they do not accept. Okay, so overall, I'm a big fan of this. I'm a bit wary to put everyone in the citation file without their explicit permission, though. I feel we might need to tag each one and ask for their permission. If they do not accept, they should stay in the contributors.md file. As a note, I think moving forward, we should use the citation.cff file exclusively, and move away from the contributors.md file. Okay, I'm just gonna comment here. Let's see. Gotta go. See you, Cosmic. Thanks for stopping by. So you get a new button that lets you pull it into a container and run it and edit it in the browser or editor without affecting anything else you have running. I'd be worried not to put them there if we didn't. This is a good discussion to have. Because for me, so Durachi92, thank you so much for following. I think yeah, I don't know what to do exactly. Because the whole point of the citation.cff file is so that people can basically get some sort of academic credit for the algorithm archive when it's cited. Like, that's the whole point, right? A lot of people might not have their, academic stuff set up. They might not have an ORCID. They might not have, like, you know what I mean? Like, it might not be, they might not be at a stage where they want to be cited yet, if that makes sense. And then there's also the point that, the stuff that you do online is like, it's your internet persona versus your real life persona. And, sometimes you don't want to mix those. Like, I don't know, like, I feel it's a bit, I can be convinced otherwise. I'm just being, I don't know, it just doesn't feel right for me just to put everyone in there, especially because, like, I don't know everyone's ORCID ID. I don't know if they even want to be cited in this way, all this kind of stuff. So, yeah, I don't know. Besides, when people committed stuff to the algorithm archive, might have been 2 years ago, and might be that since then they've actually gotten an appropriate ORCID ID and can do this, and I don't know. I really don't know. Okay, so I think we'll come back to that conversation later. So the Huffman encoding thing, we'll take a look at that next. I don't know if I can do anything here. Let's go ahead and get started here and see if we can figure out... Oh. Okay, wait a minute. Now I don't know what's happening. Yep, I'm lost. Let me go back. Okay, so Visual Studio Code backend for high performance VMs that start in seconds. Yeah, sounds good. Get started. Quick start. Try out CodeSpace in 5 minutes. CodeSpace is available for organizations using GitHub Team or GitHub Enterprise Cloud. For more information, see GitHub Products. I'd be wary not to put them. It would be someone who doesn't like to mix my. I'd be someone who doesn't like to mix my two lives, as you described. Right. I'm not saying that. I don't know. There's multiple opinions here, and I don't know which one's right and which one's wrong. Which is why I think we should talk about it. Okay. So navigate to your template repository. So introduction. In this guide, you'll create a code space from a template repository and explore some of the essential features available to you within the code space. From this quick start, you'll learn how to create a code space, connect to a forwarded port to view your running application, use version control in code space, blah, blah, blah. So okay, so I know nothing about Visual Studio Code. So what I think I might do, so this is obviously advantageous because it means that we can use the Docker container to do reviews. This helps everyone out who wants to do reviews. It really does. So I think this is a good thing to do. Name your repository, select your preferred privacy setting, and click Create Repository from this template. So can I just go here? Okay. And then say, click Create Repository from this template. So use this template. So I can put this in the algorithm archivist. Navigate to the main page of the newly created repository under the repository name and use code in drop-down menu. Sign up for the beta so you can go on the wait list. We can talk about it later. Okay, so how do I sign up for the beta then? Or can I just keep doing this? It says try out code spaces in 5 minutes. Run the application, edit the application in the view settings. I mean, it looks like it's all here, right? Okay, I'm gonna ask a stupid question. Can I just follow this guide? Will this do it for me? Or is there more to it than that? Like, is there a particular sign-up sheet for the beta that I have to get through before I'm allowed to work on this? Let me get some water. And I guess in the meantime, let me remember what was happening here with this guy. I really don't remember. So using test, did I change the line numbers? I don't think I did. Oh, maybe because Huffman encoding doesn't need to have a change in line numbers. Okay. Go to a PR in the algorithm archive. I had to sign up for it. Pull requests. Here, algorithm archive. And any PR will do. They may have released it publicly. Okay, so let's go to Euclidean algorithm in Crystal. Okay, so what do I have to do? Because I think according to the quick start, I could just go. So navigate to the template repository. Click the code drop down at the top right corner of this PR. Code. Check out with GitHub CLI. Okay, I see. So you're saying that work fast with our official CLI. Okay. So, right, how do I sign up for the beta then? Wait, trying to figure it out. 1 second. Okay, so navigate to the main page of the newly created repository. Under the repository name, use the code drop-down menu, and in the code spaces tab, click plus new code space. Okay, so we have to get in the beta. Okay, that's fine. I just had to double check to make sure that's what we had to do. If I can figure out how to get into the beta, that would be really nice. Probably I got an email about this and I didn't look at it. Let me go back a bit. L maybe? Yeah, okay. Blazing fast, cloud developer environment, let's get started. Okay. Oh, sorry for the yawn. Okay. Let me take a look here. And let me go ahead and finish up this code. So conversation. What were we looking at? So I think I held up on this PR because I wasn't sure the best way to test it. I think the integration test approach is sufficient for what we want to do. We standardize anyway, so we might as well do it that way for now. Okay. So let me see, what do we have here? The issue, I don't remember the issue with Huffman encoding. I think the issue was that we didn't have... Did we... What was the issue with Huffman encoding? Let me go to the issues. And let's look for Huffman encoding. Standardized implementation input and output. Okay. And then we also have edge cases fail and Huffman encoding. Right, perfect. Whenever any, so what did we say we wanted to do here? We said, 1 second. To make sure I'm following, we're thinking about either returning 0000 or CN. That's not exactly it. I'm thinking or returning either this or that. Okay, so we're returning just a bunch of zeros. Let me make sure that my current Huffman implementation returns a bunch of zeros. That's what I need to double check. Then here for Huffman encoding, right here. Okay, so then what I need to do is double check to make sure it's actually doing what we expect. So let's go there and check it. I missed the beta window for now. Oh man, I'm sorry. That was my bad. If I would have known, I could have signed up for it. But it sounds perfect. Like, honestly, it sounds great. Because if we could provide a review like container, like the one that you have, but if we could make it more easily accessible, that's great. Honestly, really nice. Specifically for just getting more people into the reviewing process. You know, or reviewing languages that are just hard to set up. Like, for example, Swift or whatever took me forever to set up, you know. Are you a professor? No, but I do have a PhD. I got my PhD 2 years ago, and I now do independent research to some extent. Okay, CD projects, algorithm archive. All right, ls here, over here, CD projects, algorithm archive. Now, what am I going to do next? Git branch. Git checkout. There we go. There should be like a Huffman. What did I call it? I called it Julia Huffman fix. Did I delete it locally? Oh, I might have. Okay, let's go ahead and pull it. All right, let's go here. CD Project Red. What is Project Red? Oh, wait, Communist Smeagol. Okay, maybe I get it. All right, let me fetch it from my own origin, I guess. What's it called? Huffman fix, probably. Okay, and then git checkout. Git log. I think that did it. Fixing chapter 2 split op code. Add C++. Wait a minute. Am I an idiot? I might be an idiot. 1 second. The Docker file makes it 10 times easier to get it set up, but I still need to write docs for all that still. It's not as plug and play as the code spaces. Right. But for anyone who opens it in VS Code, it'll work. Right. What are you working on? Right now I'm working on the Arcane Algorithm Archive. Yeah, algorithmarchive.org, like Nick just put out. It's a book on algorithms where you can switch out the language, essentially. So right now I'm just fixing a bunch of PRs and issues and stuff that have come up over the past week, and slowly working our way through the backlog of just many different things that need to happen to make this this project a reality. Let me do git pull, git branch, git pull, origin, Julia Huffman fix. I'm dumb, but that's okay. All right, CD projects, CD contents, Huffman encoding, ls here, CD code, Julia, ls, and now we're just going to take a look at Huffman.jl. G down here. So we do a bunch of tests for 2 pass Huffman, and let's just go ahead and run that. So we're going to run Julia Huffman.jl. Julia add data structures. All right, give it a second to go. Psych, I'm actually back. Welcome back. Decided to take a short break to consume sandwiches with mayo and diced ham from oven because Russian food is weird. Not sure if for long though. Well, welcome back. Hopefully you'll stay for a bit, but you know, if you gotta go, you gotta go. I understand. I mean, diced ham, I can't compete with diced ham. Let me take a look at 890. Full requests. Let's go here. I'm on the wrong. I got it now. All right, where's 890? Right down here. Perfect. Let's do it. You know, Nick, we really should add you to the group. 1 second, let me go ahead and do that. I just now realized that you're not part of the organization, which is crazy. I'm really bad at this. Let me go ahead and add you in. Let me do files change, review changes, approve, say if it's good with Nick. All right, submit review. And now let me just go ahead and do it right now so I don't forget. Squash and merge. Up here, what am I going to do? I'm going to go to the algorithm archivists here, and we're going to invite someone. Wait. I need to... people. Right. And then what we want to do is, I guess, invite a member. Yeah, let's do it. Nick Tyndall. And Tyndall is what it is. Yeah, there we go. Invite. Wait, let me make sure I'm not sharing anything I shouldn't share. Okay, good. Use security key. Never mind. I'm so stupid. I'm so stupid. What did I do? There it is. You guys didn't see what I just did, but... Okay. We want to do... development. Perfect. Send invitation. All right, perfect. Done. You can see my bank API. How did you even see that? Oh, no. I didn't even go to my bank. All right, let me just go back over here. Right, so we said 890 was merged. I believe that's done. So let's go and take a look at the Huffman encoding, make sure it's good to go. What is this? Oh, we couldn't do code spaces just yet. Perfect. We'll work on the citations.cff. Right, Huffman, that's where we're at. Let's go over here. And now we're just going to include, 1 second. Include Huffman.jl. Okay, Russian food is food. That is Russian, and it is weird because Russians are weird, and their creativity food goes burr. Why is Russian food, and what is Russian food, and why is it weird? I got it now. Okay. Good. So the next thing I have is a bunch of Huffman. I have 2 past Huffman, right? What I want to do, so a bunch of B's turned into a bunch of zeros. It looks good to me. Okay. So in that case, then I think we can go ahead and merge. So we're gonna do Euclidean fixing Huffman and Julia test conversation. So what do we have here? Is this finished? Is Amara still in chat? Can I ask? Okay, then I think, unless I've forgotten something, I think this PR is good to go. Should we merge? I'm so sorry. I feel like I'm missing something in this conversation. Okay, so with the Huffman encoding, here's what we did. We did the files changed. We have a test now with Huffman encoding. We fixed it so it outputs all zeros or all ones, depending. Are we good? Can we go ahead and merge this guy, you think? That's my... I'm sorry, you're getting a bunch of questions. 0, is that a times, not next? ADH, thank you so much for following. Really appreciate it. I've noticed that we've gotten a bunch of people to follow that have like, well, essentially like hex names and stuff like that. So, okay, we'll go here. And I used to just call people who had like hex like names, I used to just call them hex. That's what I'd call them. But the problem is we now have multiple hexes. So I don't know if we should be calling like one person hex 1 or hex 2 or hex ox would be, I don't know. I don't know what to do with people when I can't like phonetically pronounce their name at all. Okay, so I think this one's good to go then. I think. Euclidean algorithm and crystal edge cases. So that means this one should be solved for Julia. Let's go up here to the top. Oh, Julia's checked. Perfect. I don't really like the print line before the return, but oh, I see. It was the print line before. Right. I forgot. I'm sorry. Okay, that's what we were missing. Okay, let's do that. Files changed. Where's the print line? Let's just fix it now. Screw it. All right. Control D. vi huffman.jl print line. All right. So we have print line codebook. So you don't like. Wait, which one? Wait, which print line? Print line before return. Oh, in the 2-pass Huffman. I see. So these guys here. There. All of those guys should be removed. Right. Outside of that, I guess it's fine to go, right? I think. Okay, let's do git add huffman.jl git commit -m removing print lines. All right. 1 second. Julia Huffman. All right. I think I need to do --force on that guy because I think I merged. Oh, okay, that seemed to work. Okay, so I think I removed the print lines. Refresh. Let me just double check. We can add a main later for output standardization. Right. Right. So that was the other thing. So right now I just kind of have everything in it. Oh no, that's not what I wanted to happen at all. Okay, let me, I screwed up. Yep, I screwed up big time. All right, yep, I know exactly what happened. That was my bad. So I now need to do something to fix that. Crap. Okay. Okay, what do I do? So if you look now, what happened on the PR is now I've added basically every file that's been changed to the PR on accident. I did not mean to do that because I had a merge in there. So should I rebase onto master? Right. Git status? That was my fault for having a merge in there. I should not have had a merge in there. That's all right. Let's let's figure this guy out. Okay, so here's what I'm gonna do. Git revert. Yeah, that's what I should do. But the problem is I don't know what the old commit was. Oh, I can find it on GitHub. Yeah, I can find it on GitHub. Okay, let's go here. There. That was my bad. Oh no. I can't believe I did that. Okay. I believe this is the one that we're looking at here. Let me double check. I'm just gonna check this out just to make sure. Check out this guy. Here's what I'm gonna do. Git stash. Check out this guy. vi huffman.jl. Perfect. Okay, so here's what I'm gonna do. Git checkout Huffman Julia Huffman fix. Okay. So I did something stupid. I need to fix the stupid thing I just did, which is gonna be, yeah. Let's just do it. Git revert here. Kid not revert, fixing Huffman Julia, adding test. Merge conflicts and contents. Git status. vi huffman.jl. Right. Okay. Get status again. Dot get add Huffman. Get rebase continue. Status. What was it again? Get restore staged to unstage. Get revert abort. Get revert continue. Okay. Get log. Revert fixing Huffman encoding for Julia and adding test. Removing print line statements. Merge branch Julia Huffman fix. Fixing chapter to use split op code. Okay. Can I just get rebase master? Okay. That'll work. Okay, I think we're good. So now if I do git push, origin Julia Huffman fix. I think I have to do double dash force. I don't think that's gonna work out of the box. But, yep, that's what I thought. Double dash force. Whew, I am flying by the seat of my pants right now, aren't I? All right, let's see what we got here for the conversation. Ugh, that's not what I wanted. Did I just screw everything up? How did I do this? I'm an idiot. Oh, I know what happened. Okay, I understand exactly what happened. Right. This? Okay, look. I know I shouldn't keep get force pushing, but like, this should be it, right? This should be correct. Now, I've pulled the latest master, I rebased onto master, I think I'm good to go. Nick Tyndall, thank you so much for cheering a bit. I'm gonna use that as, so git push origin, Julia Huffman fix. Well, let me just, Alice here, huffman.jl, vi huffman.jl. Go down here, make sure there's no print lines or anything funny going on. All seems fine. Now we do git push origin Julia Huffman fix. Double dash voice. Oh man, let's see what happens. Refresh. Please just be one file changed. Yeah, one file changed. Let's go. Is this correct? Conversation. Files changed. Shoot. 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 Oh no. Well, I'm an idiot. Yep, I knew it. I knew I shouldn't have done that. I don't know why I did that. Why did I do that? I don't know. I don't know why I did that at all. Okay, so now I screwed up everything. So let me go back over here. Conversation. Dang. I can't believe I did that. Well, I have to redo this entire PR because I was force pushing because I thought I knew what I was doing. Oh, wait. No, wait. Maybe I'm okay. Oh, no, I'm not okay. No, I'm not okay at all. I screwed up. Nope, here it is. This is what I wanted. What happened? Why don't I have this commit anymore? Okay, remove print line statements. Wait. Go back. Fix Huffman encoding and adding Julia test. Oh, this reverted the... This reverted the other things. I don't know what get reflog does. Yeah, but okay, so I see what happened. This reverted the changes that I had. Okay, so I actually want to go back one. I want to go back one is what I want to do. Right. Okay, so I want to go back one. Git log. Yeah, so it's the revert that I want to get rid of. So we're going to do... yeah, it's a deep log of all the changes made. I see. Okay, well, I actually just want to be on this commit. That's the commit I want to be at. So I think I can just do git reset hard onto this guy. Okay, vi huffman.jl, go down here. Yes, this has a test set in it. It doesn't have the print lines. That's what I want. Wait, interactive rebase is better than this. I now see what that part of your job entails, Nick. Right. Anyway, I think this is okay. I should have done git rebase -i. I should have. But this is the commit I want. I'm 92.5% sure this is where I'm supposed to be. Let me just double check to make sure that that last commit, yeah. So this guy removed test. It basically removed everything, and I'm like, that was my bad. Okay, so this should be fine then. Quit here, and now I should be able to push that, and then we should do that. This is half of my life. Honestly, when I was working, like, doing Git stuff is also like a large part of my previous job. Just like messing around with GitHub, figuring out how to get all this stuff to work. It's one of those things that is like, I realize other people are probably better at Git than I am. I get that other people are better at Git. Anyway, my point is that I will go and proceed to learn limits. All right, see you, Cosmic. Have a wonderful time. But at the same time, I feel like, learning Git and learning version control is like kind of essential to doing software development nowadays. Git branch, Git log. Okay, Git push. Origin master. Where's... Oh, no. That's not what I want to do. Okay, this is it. This is the last one. This has to be it. It's perfect. I've made no problems. I have made no problems whatsoever. This has been so far perfect. Perfect Git foo. If anyone says anything different, they don't know what they're talking about. You think it's essential, but you can just pay one person to know how to fix everything when it goes wrong. Right. I mean, that's the thing, though. I guess that was kind of what I was trying to get to previously as well. Like, knowing Git is essential, but the problem is no one knows Git. And everyone who learns it, when they're learning it, it's like, man, there has to be a more effective like version control system than this one. And look, there might be one, I guess. But yeah, so let me double check this code to make sure it actually does what we expect it to do, and then we're good to go. It's nice to know Git until you go work for a company that uses Perforce. I don't know Perforce. But look, I mean, the fact is there could be many different version control systems that could work. It's just that this is the one that's most popular in open source, and people are going to be like, why though? Why is Git the one that everyone settled on? I don't know. I mean, like, if you looked at where we came from, it's actually pretty good. I don't know. All right, let me just double check here. I'm going to go into vi huffman.jl, and I'm going to do one thing just to double check to make sure that we're actually getting the appropriate bit string out, and we're just going to print line bit string here. Perfect. Julia. Oh, screw it. Julia Huffman.jl. I'm just double checking. Yeah, it looks good. Okay, so the tests are all passing. Okay, so I believe we're good to merge. Oh man. Perforce is a centralized version control, especially loved when your company doesn't want the source to be public. Oh, speaking of public, oh boy, there's been some drama in the open source space recently. Poxo15, thank you so much for following, really appreciate it. Everyone settled on Git because the Linux kernel code uses it. That's probably fair. Conversation, I'm gonna go down here. Should we merge? Comment. All right, it's up to you, Amaris. If this is good, we're good to go. Otherwise, just let me know what I need to fix. Sorry about that. Right, I wanted to mention one thing. Okay, maybe I shouldn't mention this. Okay, do you guys want to hear some open source drama or not? I feel like everyone's gonna say yes, but the problem is it's political, right? So on the other hand, maybe the answer should be no. Or maybe I should just talk about it, and anyone who care. Okay, you know how Donald Trump, is creating a new social media platform called Truth Social. Truth Social, open source. Right? Here's the thing. He basically is making a new social media platform called Truth Social or whatever. I'm not going to talk about whether this is a good idea or bad idea. I really don't care. But what I do care about is they apparently built this off of Mastodon. Mastodon, I believe, is GPL license, which basically means it allows anyone to use the source code so long as that source code is also open source. Truth Social has done the direct opposite of that and said literally in their user agreement says any attempt to modify or backwards reverse engineer the source code is strictly prohibited. So they not only took open source code and used it improperly, but they're also doing the direct opposite of that in their user agreement. So yeah, we didn't use Mastodon for that reason. Exactly, right? Like if you want to, it's fine. If you want to use open source code, great, but also abide by his user agreements, and in this one happen to have user agreements that basically enforce that you have open source software to continue. Anyway, that's all I wanted to say. That I found this kind of, I don't know, I didn't know if I found it funny or just sad. I really had no idea. When you fail to understand GPL, personally, I don't like it. Right. Oh, is this closed? Oh, no. No, that was my bad. I'm the one that keeps saying this fixes that, and then it merges it. Okay, I need to learn. Let's see. I need to learn to stop saying this fixes that without. Okay. When you fail to understand GPL, personally, I don't like it. Yeah. So again, we can go back and forth on whether it's whether GPL is a good or bad license. Personally, I don't use it. I use MIT because, I feel it is prohibitively restrictive. But at the same time, they literally took free code and couldn't figure out how to use it. It's just kind of like I don't know. I don't know what side's correct here, but I am happy to see people at least talk about open source licensing in the public sphere. I think that's really cool. And I'm now realizing how big of a nerd I am that this is cool to me. Okay, so let's go ahead and remove some of these guys. I'm going to be right back. Give me just 1 minute. And then we're going to take a look at some other issues and PRs that we might be able to handle right now. And then maybe jump into some Julia stuff. I got a notification I have to look at over here. I always use my ISE, which is MIT, but removes part that isn't needed anymore because of the Bern convention. What is the Bern convention? Go ahead, say that. I'll be right back. Let's see. I like that it's against their terms of service to decode their Flash, as if they're still using Flash. The Berne Convention is an international copyright agreement. Sadly, not all countries follow it. Oh, interesting. In short, it removes part of the permission is hereby granted free of charge to any person obtaining a copy from MIT. Interesting. How are you, Lightbook? I hope you're having a wonderful day. I'm doing okay. Thanks for asking. Okay. So we've actually done a few PRs already. I think 3 different PRs. One of them we haven't quite figured out, but we're getting there. Let me take a look at any other PRs that are probably quick to merge. Otherwise, we're going to move on to the Julia thing that has been royally screwing me for the past, I don't know, like, I did 5 days, 6 days? I don't know. I'm just gonna put a little smiley face in here as well. I can't believe I accidentally closed that. That is really my bad. All right, let me go up to the top here. Files changed 20. Yeah, this looks right. Okay. I'll let Nick and Amaris continue their conversation here. Monte Carlo and Crystal, C# tree traversal, computers Emacs, in Emacs Lisp. Ooh, okay, that's a thing. Berquist, my friend. Who knows Emacs Lisp? And what is the difference between Emacs Lisp and just normal Lisp? Okay. Barnsley, Fern, and Python. This one should be good to merge, right? Oh, there were some discussions here. Right. Okay. So that discussion isn't finished. Tree traversal output standardization. What's this guy? This standardized language implementations for the tree traversal chapter is based on 885. Okay, I believe then this is good to go. Let me go back here. What do we have here? Doing this for readability in accordance with new output format. Then in that case, we have to resolve some conflicts. Oh no, what are the conflicts here? Contents main class tree, main class.java, tree.java, tree.jl. Uh-oh, what's going on here? Am I allowed to, okay, I'm gonna ask a stupid question here. As one of the primary maintainers of the algorithm archive, how can I push directly to this branch? Because it looks like there might be a few... Okay, so first of all, I think this is almost ready to merge. Funnily enough, the EU advises to use MIT over ISC, but only to reduce license proliferation. That's probably fair. You can push to their branch. Oh, can I? Can I directly push? All right, I'm going to ask a stupid question then. How do I do that? So what I'm going to do is I think I'm going to pull their branch locally, and then we're going to try to do the rebase, and I'm going to try to push to their branch, see what we can do. I don't know. I mean, if it works, it works. Command line instructions. Right, so we're going to git checkout here. Okay. Let's go cd, back a couple directories, one more directory, git pull, upstream, master. We really should change that to main. I just haven't done that yet. Merge. No, I don't want to merge. Ah, there we go. Perfect. Okay, so the next thing I want to do is pull their branch. Git checkout B should be fine. Okay, so now, we're now on their branch. Git checkout master, git merge, no fast forward. I don't want to merge it. I want to rebase onto master. So if I do this, it's gonna ask to merge. This is where my Git skills have, I keep forgetting how to do this. And luckily for me, since MIT and ISC are basically the same, changing between them should not cause any issue. Right. I mean, I think if you do a license change, don't you have to get every single person who has like written code for the code base to agree to the license change? Otherwise it's not legally binding specifically for that person, right? or the code that that person has written. We actually had to do that early on in the algorithm archive because I was dumb enough to add in the wrong license, or we didn't really. It wasn't clear whether the MIT license extended to different parts of the book and all this kind of stuff. So, okay. So what am I gonna? I guess I'll try and get poll, but this is gonna merge. No. Here's what I'm gonna do. I don't want this to merge in. I want to. I guess if I merge and rebase, it's fine. No, that's not fine. Okay. What am I gonna do? I'm going to take a look at which branch where this came off from. Here. I'm the only dev on my project, so I just need to get the permission from myself. Oh, that's totally fair. Rename tree traversal.py here. And this comes from... Wait. If I could figure out where this came from, then we could go back there and we could then... Wait, I need to think about this. Commit. Git fetch and then git rebase without the poll. Oh, can I just okay, if I do git, yeah, there, you're right. Git fetch. Then git rebase mess, git log. No. Okay, wait a minute. I need to think about this. So can I do git rebase? What am I rebasing onto? I guess is my question. So I've got a git fetch. I then did git checkout, git branch. Okay, so do I need to do git fetch? This guy? Okay, no. Sorry, I'm learning some Git today, apparently, which is good. It's good. It's always good to learn new skills. Okay. Git fetch makes it aware that there are other places it can move. So, okay, so my question is, what does git rebase do in this case then? Because I want to rebase onto master, but usually I do that from the branch onto master. So git pull rebase would work. Oh, okay. So if I do git pull rebase, should I just press enter? I'm so sorry. I need to learn this stuff. But like I said before, it's something I use Git all the time, but I'm not necessarily a Git master. It's one of those things that I need to get better at. Okay, so let's try this then. Sure. Please specify which branch you want to rebase against. Okay. If you want to set tracking information for this branch, so I want to do git pull rebase. Okay, so should I just do master, or I specifically want to pull git pull. One second. Let me take a look here at the conversation. Go down to the bottom here, and I want to do git pull this guy. That's what I have to pull? So if I do this and then rebase, it should work. That? Or am I dumb? Sorry, I'm waiting a second to make sure I'm not dumb, which I probably am. Let me get a little bit of water. And I guess in the meantime, I'll just run AskAquarium in the left terminal. Wonderful. Okay, no one's saying no or yes, so I'm gonna just go ahead and run this. Okay, so where are we? Merge conflict and contents tree traversal, Julia tree. I had capital J.jl. Interesting. Okay, so we're gonna cd into contents. tree traversal, and then code Julia vi tree.jl, and let's look for head here. What do we want it to change to? So this is head, is printline first s.id, printline I, printf. Wait, why do we have an at printf in here? Oh, I bet you it's changed to at printf so that, yeah, all the rest are at printfs. So let's do that. Wait, does this mean that from now on we have to use at printf for Julia instead of printline? Am I dumb? That's a question I ask myself daily when I make stupid mistakes. Okay, well, it's fine. For now, we'll just use at printf. Okay, let's just do it and see what happens. So let's do Julia tree.jl. It's not a unary operator. Okay, yeah, I'm done. Here, okay, so the other one's at printf. What about the print line in the else statement then? Wait, let me check. There is definitely a print line here, but that only happens if... Wait, what is going on here? Yeah, why did we change to at printf? Let me check what the algorithm archive is here. Where are we? Tree traversal should be here, perfect. And then we go to Julia, should be fine. Yeah, why did we change to at printf? Okay, I'm gonna ask that question in the review over here. Files changed. And let's look for at printf. I'm just gonna ask a stupid question. So this is specifically for oh, let's run the code, see what happens. Right, let's just run it. So we're gonna run Julia tree.jl. Okay, so this does, okay, it outputs it in a different way. This is fine, actually. This is actually a pretty decent idea. What I might ask is maybe, can we change this to just at print? Or just print? Let's do at print. I'm gonna put this here. Okay, let's go and start the review. I'm just gonna ask the question. I think at print does the same thing. Oh, I see, but specifically because they need a space in between. Okay, I see. So it might be... One second, n.id space. Yep, update comment. Okay, that's totally fine. That's not a big deal at all. Git status dot git add tree.jl git rebase double dash continue. All right, what's the next one? Git status. Deleted by them Java main class.java. I guess it's fine to delete. So what's the issue over here? So the issue was, I think that Java was deleted and then it was replaced by another file with another name, I think is what happened. Conversation. It looks like, yeah, it looks like it changed from main class.java to tree.java, which I guess is fine. And then they added tree.java. Okay, let's just do that really quick. cd backup directory into Java, ls here. Vi, I guess just git rm main class.java. Now, I guess my question is, did they update the chapter so this was up to date? Let's go into vi tree.java. Yeah, it must be the same code, right? Okay, that's fine. Let's take a look just to make sure. Okay, good. So I think we can just do git add dot, and then I think I can push locally with the changes. Nice fish tank. Thanks, you too. Okay, so we're gonna do git add dot git status dot git rebase -- continue. I guess this is fine. All right. Could not apply git status. Both modified tree.java, vi tree.java, head here. Okay, what are we looking to change? Looks like, how many things do we need to change? Just this one. Thanks, you too, really? Sorry. For some reason, anytime people are like, thanks, I'm like, yeah, thanks, you too. It's just naturally, I don't know. I always do that. Sorry. What is this supposed to be? Not a binary tree, depth first search, recursive in order. Is this supposed to be Java tree traversal? Was this changed recently? I feel like this was changed recently. Let me see. Commits, pull requests here. Let me look up Java. And let's look for closed. Merges today. Okay, right. We're gonna search. Java tree traversal updated DFS recursive binary. Let's go here. Perfect. Okay, so we need to change it to this one. Second one. Okay, that seems fine. Right and quit. How do you run Java? Right. Sort recently updated. Okay, now the question I have is that this is using recursive depth first search. Sort recently added. Wait, which was the... Oh, well, okay, right. Let me go back to the Julia implementation. And let's run Julia tree.jl. Uh-oh, did I screw up? I think I did. I think I did. Okay, I now understand the problem. Because it was changed to tree.jl, but they made all the changes to main class.jl is what happened. Files changed. Can I just ask them to rebase up? Maybe I should just ask them to rebase up, because I feel like maybe I shouldn't be doing this work for them. And I should just mention there was a change to the Java implementation here, and just say, would you be able to rebase up? And if they say no, then I'm like, okay, I'll do this, because otherwise I might screw it up. And I think that's what I should say. So we're gonna go to conversation. What number is this? This is number 899. Oh, it was just today. You guys said it was just today. Okay, so let's go ahead and review the changes and say, this looks great. Could we rebase onto master? Note that there are some changes to the Java implementation here. Wait, number 899. Okay, I'm just gonna ask them to rebase up. Is that okay? Like, I think that's what I should do. Submit review. Oh, I get it now. Recently updated. Yeah. Okay. Nice language tags. Oh, I didn't realize there were so many. Okay. What am I gonna do next? I think I'm just gonna leave this for now. Git rebase -- abort. I don't know if merging this. Well, no, I think it's fine. I mean, someone was gonna have to rebase onto something else. It's fine. We'll just see how this goes. If they have trouble rebasing, we've shown that it's actually not too difficult to do. It's just we have to be a bit tricky with the tree.j Java file. Git checkout master, and we know what to do now, so we'll figure it out. Right. Git pull upstream master. Perfect. Okay. Git push origin master, just to get my own master up to date. Perfect. Okay, I think that's good for algorithm archive work for now. Again, maybe we'll come back to it later today, but we made some good progress today. I'm pretty excited about that. What I want to shift to is a brief discussion on basically everything that has broken in Julia over the past 3 days, 2 days, whatever. Cases Swip Peel, thank you so much for following. Really appreciate it. Sorry that I completely butchered your name. So I'm going to open up a few more terminals because when I get scared, that's just what I do. I open up more terminals. I don't know why. It's just my natural defense mechanism. How are you doing? Okay. So we're now going to CD. Over here, we're going to Control C, CD, and we're going to talk. I was annoyed by the number of language tags, so I created a standardization tag. That sounds perfect. All right, let's go to clear here. I don't know where to start this conversation. What terminal manager is this? I'm currently just using Xterm, like literally just UXterm. That's it. It's I could do something nicer, but I'm not. So I used to use Xterm explicitly because it has Sixel support, which is the support for like playing animations and stuff in the terminal. Here, I can show you, I think. So if I don't know what I can show you though. Let's CD into projects. Simuleos, no, Flamify. Now let me do, what is it, L6? This, and it will show the images, yeah. So what else can I do? I think IMG to Sixel, I believe. And if we do, what am I going to do? 1 second. I'll make this full screen for a second. And if we do save4.png, you can just show the image directly in the terminal, which I thought was really nifty. So I was like, I like that. Save 5. Save 3. Yeah, so you can just show it directly in the terminal, which I thought was really cool. So I was like, that's really nice. So I started using it exclusively. And then I started using Julia a lot more and realized that Julia needs Unicode support because for some reason, everyone in the Julia language decided that they're just going to use Unicode for everything. And Xterm didn't have Unicode support. And I just couldn't get it to work. It was such a pain. Anyway. I want to get back to the day when I can use that regularly, but I haven't recently. Okay, enough dilly-dallying. Let's go ahead and get started with the next bit of today's stream, which is talking about kernel abstractions. Kernel abstractions. Let's open up Xernal PP. And let's go. Also, let me try to change, I don't know how to do this. My side screen is just kind of like, I have not quite figured out how to make the Twitch UI useful, if that makes sense. That might be it. No, that didn't work. 1 second. I'm gonna maybe move this down. That should do. Okay, good. I think this is okay. Well, maybe not. Let me refresh. That is my side screen. No one cares. Okay. Move this over here. Gotta go. See you, Nick. Have a wonderful evening. Thanks for stopping by. I just screwed it up. 1 second. There. And okay. All right. So I think that should be good. Perfect. Thanks again for all the help today with the algorithm archive work and everything else. It's really shaping up again. It's been a long time since I've felt hopeful for the algorithm archive to be a big thing. It's been a while. Okay, so what is the issue? I've been working on this bug for the past 3 days. It is a very, very simple issue. It is with the following command: int convert int32 object, we'll call a, of type int, of type any number. This right here has been the bane of my existence for the past, like, I don't know, like 4 days. Honestly, it's been a pain. It's been a huge pain. And I guess I'm just going to talk about the bug and see if we can just kind of work with it. So what is the actual issue here? So the actual issue is that we're using a library called kernel abstractions. The point of this library is so that we can write a single code base that executes on both the CPU and the GPU, not at the same time, but it can execute on either. So specifically, when we're executing on the GPU, for some reason, when we try to convert any symbol, like A, B, C, or something like that, into an integer, it fails. Now, look, converting to float works. Pretty much any other function call works, but specifically converting to an int32 fails. Or an int64 if you have a floating point precision number. I know why. I can't fix it. I think I know why. I went from I know why to I think I know why to I probably know why. And actually, probably in a matter of 30 minutes, I'm going to say I probably don't know why. But let's talk about what's going on. So first, I'm going to show you the bug. So we're going to cd into projects. Let's just use Simuleos histogram. Over here, cd projects, Simuleos histogram. Okay, the first thing I'm going to do is just open up the file that I'm working with. Minimum working example 2.jl. Don't just ignore my stupid schemes, okay? I've dumb naming conventions. Here's the kernel function ftest kernel TID. This is your thread ID. When you're working in parallel, you just grab which individual core on your GPU you're working with, kind of, sort of, and you say, do this thing. So all I'm doing is I'm converting whatever this thread ID is, which is an int64 value, onto an int32. That's it. That's all I'm doing. I'm also going to go over here and open up kernel abstractions. So we're going to cd projects, kernel abstractions. So I have one set of terminals specifically for kernel abstractions, and another set for the minimum working example. We're going to go to vi source, and it should be something with a C, compiler.jl. Let me go down to in exact error here. I'm going to comment all this out so you don't see any of my mess. Okay, I'm going to go over here and I'm going to run Julia. As Julia 1.6, we tried Julia 1.4, we tried Julia 1.8, we tried so many different Julias. All of them came up with the same error. Now, what I'm going to do is include minimum working example 2.jl, and we're going to give it just a second to precompile. And you'll see the error. And I'll show you exactly what's happening. Exactly what's happening. And my hope is that we can kind of figure out how to solve the problem. The error message is ugly. I've been looking at it almost exclusively for the past 4 days and pretty much nothing else. And my hope is that someone here, and look, I'm not super hopeful, but my hope is that someone here can help me with this. So I'm gonna move this down a bit, make it big, huge, so we can read it, and maybe full screen it actually. And let's take a look at the error. So first of all, it says load error, invalid IR error, compiling kernel, GPU F test kernel. So this is just saying there was an error in the compilation of our test kernel that we created, okay? The next thing it says, oh, I hope I still have internet. 1 second. Yeah, okay, it says I'm fine. For some reason, my laptop lost internet. Does it have to be an int, or could you just use float instead since it works with floats? Well, we specifically for this kernel need to use an int32. It's meant to be a particular implementation of a histogram algorithm, so we need int32 for this. Now, again, we could technically use something else, and we could like get around it. But I would prefer if we could use int32 because that's the actual algorithm. It kind of requires it. Okay, I'll just make this big like that for now. Okay, so we then have all these issues. So we have these issues with overdub. So what is overdub? Essentially what's happening is you write a single code base that is then overdubbed into the CPU or GPU version. So this is you rewriting the kernel so it can be executed on the GPU. We then have this error with throw inexact error. The inexact error is an error that you get in Julia when you do something like this: int 32 of 1.2. It doesn't know exactly how to convert that onto an integer. And so what it says is, well, it could be anything. It's inexact, this type of stuff. But if you do 1.0, it'll work just fine. Now, the other way you can get an inexact error is if you try to do int 32, but you have a very long number, something like this, right? And the reason that happens is you can't truncate it appropriately onto an int 32 value. So for that reason, it also grabs the inexact error. Okay, so that's the inexact error. And then you have overdub to int 32, overdub to int 32. Again, it's just int 32 instead of to int 32. Convert, which is the call that we did in the kernel, and then all these overdubs. Then we have over here, unsupported call to Julia runtime, JLF get field, inexact error, symbol type int 32, int 64, inexact error, blah, blah, blah. Okay, so what actually is the issue? I'm going to show you the issue here. So we have JLF tuple, unsupported call to JL runtime, JLF tuple, and JL get field. Now you might be thinking, all I'm doing in this kernel is converting onto an int 32. Where is the tuple? Where are we getting a field? I don't understand. Here it is. I'm going to edit the source code. @edit, and we're just going to @edit int 32 of, 10 or something. So this is converting an int 64 into an int 32. As you can see, it calls int 32, which then calls to int 32. Let me go to 624. This thing calls particular functions in order to truncate it onto a signed integer. That's what sint stands for. And then you get this guy right here. And this is the line where it breaks on. It says equation int x, and then throw inexact error trunk. I just got in, definitely not thinking that, but I'm rooting for you. We'll see how this goes. Okay, so we have equation int and throw inexact error. Now, you might be asking, where is equation int? Good question. It's actually one of the few things written in C++ for Julia. We're really far into the Julia ecosystem here. Oh, man, my Wi-Fi is down, but I think I'm still connected to the internet. Okay, so the next thing is this throw inexact error, which is the error that we're getting. And I think this is on line 602. And here's the problem. We have throw inexact error, right? It takes a symbol, a type t, and a value, where t could be any type, but specifically here we're talking about some sort of integer type. And here's the tuple, right here. This guy here. Oh, that's the tuple that we're allocating. That's the problem, right here. This is the problem. We're trying to allocate a tuple, and we can't do that on GPU architecture. So that's the whole issue. We're going all the way down to this throw inexact error, and it's trying to create a tuple that can't exist and get an index to that tuple that is just not allowed because, again, we can't create it. So this is the problem that we have. It has to do with the fact that the way that kernel abstractions is doing the overdubbing, in that scope, we don't have the ability to just create something like this on the GPU. Which is why it doesn't trigger on the CPU, because on the GPU you have to pre-allocate memory, not dynamic static memory, for allocation of tuples and stuff like this. So this also means that every thread, in principle, would have to allocate this for itself. So it's kind of a weird double-edged sword. So what do? I genuinely have no idea. I tried so many different things over the past few days, and I found no solution that works. Everything's just kind of messy. I keep refreshing my side screen because honestly, the Wi-Fi kind of went out recently, and I don't know what's going on. Okay, so this is our random issue. Let's quit here. So let's talk about solutions then. I'm going to delete some of these pages that we aren't looking at anymore. Let's go to github.com, and let's just go to kernel abstractions here. I'm going to go to the pull request that I just created. It's a draft PR. It really didn't change too much. But what I tried to do recently is I tried to make it so we have an override for cassette, which is the thing that's doing the overdubbing, the thing that's rewriting the code for the CPU and GPU. And I tried to make it so anytime we get an inexact error, it actually calls a more appropriate form of the inexact error. That doesn't necessarily, it throws the error instead of allocating the tuple to throw the error. That's what I tried to do. It hasn't worked. It has not worked at all. And I want to explain, I don't understand why it hadn't worked. So what I wanted to do was take it so anytime we get inexact error and make it so we don't get this tuple of @inline, no inline meta, we just get throw. That's it, we just get throw. So let's see how successful that's been. Here, I've tried 4 different cases, and actually I've tried like 10 different cases. These are just the ones that I've saved because they were somewhat potentially helpful. So what I'm going to do first is I'm actually going to make it so the inexact error returns print line of arguments. Okay. So here's where things get really tricky and really annoying. So we're going to quit here, Control D, open up Julia again, and rerun it. Oh shoot, I did something dumb. I did something really dumb. Okay, Control D, reset. Okay, one more time. Julia, now we're going to do include memworkingsample2.jl. Why? Why do I not have Wi-Fi? Is the internet out? Let me double check. No, I think it says the internet's still up. Okay, well, whatever. Okay, here's a task failed exception. It's failing when it tries to generate an error. Right, it's failing when it's trying to compile the ability to generate the error. That's when it's failing. It's not failing on the calling of the error. It's failing on the function call to let people know that the error exists. That's what it's failing on. From the best I can find. Oh my gosh, this is so annoying. My Wi-Fi is out, which I use. I need to get a second monitor is what I need to get. Okay, so what is this guy doing? So this guy is particularly enlightening because I was pressing some buttons, but essentially I replaced the inexact error with a print line, and it prints out a 4 and a 1. Now, if we look at what those are the thread IDs, right? Now, this is why things are really weird for me, because what should be happening when we throw convert is convert should call a bunch of different functions, eventually leading on to the truncate signed integer function, which eventually goes on to throw inexact error. But why, how is it calling this with only one argument? How do we get to the throw inexact error with only one argument? Because anytime we go to the throw inexact error, we have more than one argument. Let me just run this one more time. Maybe this will give you a better error. Okay, so here's the 4, 1, right? And again, what I was expecting to see here was 4, type of int32, and then some sort of some sort of function call, like some sort of ID that we know has failed, right? So again, if we do the other case that we had before, where we do int32 of some large number, I was expecting it to say inexact error trunc int32. So I was expecting it to have colon trunc, type int32, and then the value of 1, 4, or whatever. But here, it literally just has 4, 1. Right, there it literally just has 4, 1. So here we have inline cassette overdub. Oh, and then more than that, it gets even weirder, because what happens next is it says no method matching multiply for nothing, nothing. Where's that coming from? I have no idea. I'm just completely lost. All I tried to do was change the inexact errors to prints, and now all of a sudden I have a multiplication symbol in there. I don't know where that's coming from at all. And then also, like, what's going on with, yeah, why? I mean, if we went through the entire, like, list of possible functions, how do we have only one item here? Because if you go to the, here, let's do another @edit. If we go here, and then we go to line 602, the only way, actually 624, the only way we can get to this throw inexact error is if we have multiple values here. So my guess is what's happening is the following. My guess is that when we've replaced the inexact error, it's actually replacing the inexact error with the wrong set of arguments. And the reason it's doing that is because these args are the args of convert, not the args of the inexact error that's found here. So it's just putting the wrong set of arguments in. So what I'm going to try next, sorry, I'm kind of rubber duck debugging here. Why? Why is my Wi-Fi still down? Give me a second. What is going on? I mean, like, is it just Twitch that's down? 1 second, let me see if other things are down as well. No, it looks like my entire Wi-Fi is down, which is a pain. I mean, like, no, Twitter's up. Twitch, oh, no, Twitter's down as well. Okay, for some reason, my Wi-Fi is off. I don't know how to fix that. Um, yeah. Oh, nope, still down. Okay, so whatever. We'll just keep going. Okay, so what I'm going to try to do next. Hey, I worry I'll never get programming and I don't know what to do. Like, I have a lot of trust and self-confidence issues. I feel like every time I mess up, I'm proving I'm too stupid and I don't trust things, I don't understand, and I like to think in concrete concepts. Right, okay, then we have BB Astronaut. So hypothetically, would it work if all the data types are correct and never needs to call the error? Well, right. So, for example, I'm going to get to your comment, Commodore, in just 1 second. So, for example, if this is int64, it would work because TID is already a 64. So let me just show you that really quick. And then I'm going to answer Commodore's comment because that's actually really important to talk about. So if I run this include, it's going to work just fine. Okay. So, Commodore, your comment here is actually a really, really important one to talk about. And it's one that people don't talk about enough. Like, because what you're feeling is, it would have worked if I didn't have, let me comment this back in. All right, now let's go back over here. What you're talking about is essentially a form of imposter syndrome, in a way. Maybe it's not full blown, it might be a different type of imposter syndrome, but essentially what you're saying is that when you're programming, you feel like you're not good enough, and you feel like, the more you do programming, the more the less you know about it, or something like this, or something like this. Again, maybe that's not imposter syndrome, but the fact is, when you're programming, there's a lot of just psychological stuff that goes on. You have to really think about how you're doing X, Y, and Z and all this kind of stuff. Like, for example, I hated algebra once the variable was unsolvable out by itself. I don't trust things that aren't intended to be understood. So what exactly do you mean? Like, how does that tie into programming? I guess is my question. I feel like with programming, most things are pretty concrete. Unlike with a lot of, mathematics, where I feel like things aren't as concrete, right? I feel like, all the unsolvable stuff with like Calculus 1 and all that kind of stuff, it doesn't usually show up so much with, doesn't usually show up too much with programming. Algebra, hey, would you like to talk about this conversation as well? Luckily, we have the entirety of algebra here. 1 second. My Wi-Fi is still down for some reason. But yeah, I guess what I'm trying to say, I don't really have a good answer for this idea that, like, the more programming you do, the worse you are at programming. I don't really know how to solve that issue. I mean, I still deal with that issue all the time. I mean, you just heard me earlier in stream just call myself an idiot, and that's what I do. And the truth is, people, I think Trash Talk even mentioned this before on stream. I'm very not demoralizing to myself. I don't know what word I'm supposed to say, but I talk myself down a lot, which might not be the best solution. A lot of people need very positive reinforcement, and the fact that I, someone with a PhD, constantly say that I'm an idiot is not essentially is not going to help people, right? In some sense, for me, it helps me because it humanizes me. It makes it so, I always keep my arrogance in check, all this kind of stuff. But for a lot of people, seeing someone who has a PhD say, I'm an idiot all the time means that, well, I don't have a PhD, then I must be even more of an idiot. You know what I mean? But I think the trick here is not really to think about it that way. Like, just attack each problem as it comes about, and really don't compare yourself to others, but compare yourself to how you were 6 months ago, right? This is something that I used to do all the time. Whenever I feel down about where I am, like, at this moment, I always look back 3 months, 6 months, a year, and I ask myself, did I make progress in the last 6 months? Would I, 6 months ago, look at the person I am now and see that person as, a fundamental programming god? Not something like that, but you know what I mean? Like, would I look up to the person that I'm becoming, essentially, is what I'm trying to say here. Like, would I, 6 months ago, look at my skills now and be like, wow, that guy knows how to program? Like, that's the type of stuff that I feel like you need to do. I feel with your library, you might point to stuff like gdi.lib, and that's a closed source black box. And even if you only use FOSS software, it's like, how does GTK work? And then it's like, how does GCC and glibc work? Then it's like, how does x86 work? Or okay, that's fair. I totally see what you're saying. And this is like different levels of abstraction, right? I mean, like, at some point, like, you can't, I actually had this conversation with my wife just literally right before stream about something entirely different. We were talking about string theory, and in particular, we were talking about particle accelerators. And I said, I genuinely don't understand the utility of this type of research. Not that it's not useful, because I know it will be useful. It's like quantum 100 years ago was not useful. Nowadays it is kind of useful, right? Like, it's one of those things that becomes useful once you learn more about the fundamental physics. But at the same time, it's a level of abstraction that I don't work on, right? Like, I work on, GPU computing. I work on, computational science. I work on things that are just fundamentally different. And when I hear that, I don't know, $1 billion or whatever goes into this thing, understanding the fundamental utility of, or the fundamental physics, I'm like, I don't understand. Why are we spending so much money on this thing when we don't even know what field it's going to produce, right? And like, I made I had the discussion that, like, when it comes to computational science, right, there will be a bunch of labs that are doing a bunch of PDE solving, and this is really useful for a variety of fields, right? So even though you have people doing more software systems engineering, that's still useful for their own research. It's still useful for different areas. But when you see someone doing like electrical engineering for, like, particle colliders and stuff like that, really it's hard to expand that outside of the particle collider zone. But my point with all of this discussion is, I don't work on that level of abstraction. I don't know where those fundamental uses are, and I'm happy enough with the level that I'm working at now. And I guess what I'm trying to say is you just kind of have to make peace with the fact that, the deeper you go, the harder it is to understand this stuff. Like what I'm working on right now, like I'm quite deep in the Julia ecosystem trying to figure out what this problem is. I found the problem, I don't know how to fix it. It's a pain, it's a huge pain. But that said, I also understand that I'm not going to be on this level for too long, and we do have to generally trust that, for the most part, if it's been working for so long, it probably works. It will continue working, right? Like, we can kind of generally trust that people know how to code, like the Linux kernel and stuff like this, That's stuff that I don't really have to delve into. There are different levels of understanding. You don't need to know how to make a compiler to understand how to use it. Right. It's the same with quantum mechanics. We have so many theories of quantum, not so many theories, but there are a lot of different interpretations of quantum mechanics, but people have kind of moved on from that. Even though the understanding, like the interpretation of quantum mechanics, is what draws people in, the utility of it, the engineering component of it, is what keeps people interested and allows for them to make new things. I feel like I can't trust things unless I understand the full stack. Like when things don't work, I feel like I won't know who's to blame. That's fair. Every time I mess up making mistakes, a lot of mistakes is a huge part of learning and how to code, learning in general. Right. But yeah, I also agree with that entirely. As far as like going back, look, there's a reason I started coding in C and C++, and I didn't start coding in Python. There's a reason I stick to Julia and I don't do MATLAB. I am very much the same way. I like to see the metal. I like to be able to at least look at the source code. Maybe I don't understand all of it. There's a lot I probably won't understand, but being able to just dig a little bit deeper and do things like @code lowered, for example. If I do @code lowered of int32 of 10, for example, what it will do is it will give me, stuff. It'll kind of be like, we're using 2int32, which we know we're using, and it would have a type assert. Like, that's kind of what's happening. And the fact that I can do code LLVM, which is the stuff that gets passed to the compiler. Like, this is nice. I like being able to see this kind of stuff. Do I understand that fundamental step of how to go from LLVM to executable code? I don't. But at the same time, I know that working at that level of abstraction would just be a nightmare. So that's kind of where I'm at here. Generally, so you saw this a few days ago on stream. I found this error 4 days ago, and I did everything in my power, absolutely everything in my power, to create a minimum working example, to try a whole bunch of different kernels, try a whole bunch of different Julia versions, try different versions of kernel abstractions. I tried everything to get it working, and I did everything I could to exhaust to make sure that it was not my fault, to make sure this was a fault with Julia, not a fault with, or a fault with kernel abstractions, not a fault with me, right? And then once I've identified that, look, I've done everything I could, I then brought it to people who know what they're doing, and that's kind of how I have to go. I heard computers haven't done math right in like 30 years, like limits. I feel like I should trust myself. What? I actually hadn't heard that. What do you mean computers haven't done math right? 1 second. Oh yeah, my Wi-Fi's up. Look at that. You guys can't see it, but I promise the Wi-Fi's back up, and I'm incredibly excited. Let's go. I can now see follow notifications and stuff again. I'm sorry. Another example, based on what you said, space. You can ask, why are we investing billions in space when we have so many issues on Earth, but the hidden benefits aren't really visible, like how NASA gave us a lot of stuff. There's a type of glass fiber for fiber optics, has many issues when produced on Earth, but not in space. Even though you don't need to know why, the benefits of zero-G manufacturing can revolutionize the world. Right. I mean, this is exactly right. I heard the branch predictor messes something up. Yeah, so this, I know nothing about that. If there's something fundamentally wrong with the underlying algebra, mathematics or whatever, I don't know. I don't know how to solve that. By the way, in the 10 minutes that my Wi-Fi was out, Psychazzer and also algebra, thank you guys so much for following. Really appreciate it. But I guess what I'm trying to say is you kind of have to make peace with the level of abstraction that you're at. I mean, there are world-renowned scientists that don't know Git. There are world-renowned scientists that have not written code since Fortran 77, and yet they're still publishing actively. And the reason this works is because, well, even people in their lab know this, or people, they work on a different level where they don't need to know the nitty-gritty details. They can work on more pictures and stuff like that, or more like direction. I'm more of a CE guy, computer engineering, than computer science guy. To me, touching the metal, I tried programming in ASM and it felt less magical than C or anything higher level. To be fair, people need ASM developers, right? Maybe that's just what you should decide to do. Maybe take some time to understand how this works. That might be exactly what you want to do then. My fiance has been working on logos for the algorithm archive. Oh no, that's okay. Let me see what those are then. I'm interested. That's a completely different topic, but I'm quite interested. Logo design. If everyone needed to know everything before you could use something, it wouldn't not yet there. No, I'm looking forward to it, is what I'm saying. I'm really looking forward to it. Yeah. Okay, because we do need a logo. I mean, we've been needing a logo for a while now. 1 second, let me go here. I've just been really bad at getting those logos in. Anyway, I'm really sorry that I can't be super helpful here. It's one of those things, but the fact that you like the bare metal stuff means that maybe that's where you need to work. Maybe that's just a level of abstraction that you want to work on. And in fact, maybe other architectures can help with that. For example, doing GPU engineering is way lower level than doing CPU engineering. Doing FPGA stuff is even lower. Maybe what you want to do is work on the different hardware. Quantum computing, for example, really close to hardware nowadays. There's a lot of these things that work on different architectures to get closer to the hardware if you want. Maybe work on ASM, this type of stuff, Your cow logo is good. I like it. Thanks, Mika. We're not talking about that. We're talking about the algorithm archive logo, not the cow logo. I want to spruce up the cow logo, but I do generally like it. Speaking of which, and not M, thank you so much for so much for the resubscription. Let's go ahead and put a few Simul cows in chat. 1, 2, 3, 4. Really appreciate that. Thank you so much. 1, 2, 3, 4. Let's go. But I really appreciate it. Thank you so much. Yeah. Okay. So for anyone who, I'm not gonna do this, but if we only have a few emotes on this channel, if you have ideas for other emotes, let me know. So for example, we have Simul Wow, Simul, oh my gosh, Wow, which is just me when I have very bad hair after swimming, Simul Julia and Simul Vi, so those are my 3 favorites, actually. Simul Cow, Simul Wow, and Simul Vi. Those are my 3 favorite emotes. I quite like them. The other ones are neither here nor there. There's Simul Julia and Simul Term as well, which are just terminals and stuff like that. Okay, so, right. I don't think we can continue this conversation on the levels of abstraction and stuff like that. I think at this stage, I know for a fact that I have a particular level of abstraction that I work on, I think it's useful to know at least a line of knowledge between what you're doing and some fundamental law if you're doing anything in the sciences. This is not about directly using it as a tool, but it makes defining explicitly any assumptions you are making about whatever you are doing possible, which helps solve the problems and innovations. Right. Yeah, I also agree with that. I think you hit the nail on the head there, saying that you want to know You want to know if you're on some level of abstraction, right? You want to know what's under you and what's above you. That's what you want to know. I like how Simulterm has Leostat Nima at the top, and no one will ever be able to read. Oh, does it actually? It does. Yeah. Okay. Good times. Good times. Yeah. It's been a long time, but I made those emotes a while ago. Yeah. I need to do better emotes. Like, for example, we don't have tier 2 emotes. There's only one person that's tier 2, and it's Trash Talk because someone gifted them a tier 2 subscription. But yeah, I think I need to do better with emotes. I'm really bad with them. Okay. Anyway, my point with all of this is saying I really don't know what to talk about with layers of abstraction, but I think that's a good way to think about things. So, yeah. For C++, I quite often use godbolt.org tool to look at the assembly. Oh, I've used that one before. It's quite nice. Look, I don't know. Everyone likes working at different levels. Again, for me, I don't like doing very much systems engineering. I do it because I feel like it's necessary sometimes for the work that I do, but that's not where my heart is, right? My heart is in my heart's not on the physics level either. It's somewhere in between the two, right? And that's just where I feel comfortable. And I feel like you just have to find where you're comfortable and work there. Okay, so let's just get back to the Julia error now. I'm sorry, that was a bit of a ramble, but it's something I think is really important to talk about because I think a lot of times people have these like discussions. I don't know, like there have been days that I'm just petrified of doing any work, if that makes sense. Like I'll be upstairs, I'll be reading a paper as I normally do, and I feel like I just can't do it. Like I just can't get the work done, or I feel like, there's just something fundamentally wrong with how I approach the problem. Just so many issues, right? And I feel like you need to talk about that, right? You need someone to talk to and say, hey, maybe approach it from a different angle. Like it's stuff that's really important to discuss, even if there aren't really good solutions. The mental game is big in programming. It's big in science. It's big in research. It's big in pretty much every technical field. Between imposter syndrome and just general lethargy and working your way through the jargon, there's so many issues like this that come up. And I think it's important to talk about. Like if you design hardware, you should know about compilers and higher level applications so developers can use your stuff. And if you do high level applications, be aware of your hardware features. Great talk. I feel inspired. I don't know. I don't know how to help people, but I'm hoping that this helped someone, Anyway, let's go back to the Julia error where I can't freaking convert something to an int32. That's where we're at in life. Okay, what I'm going to do is the following. I'm going to modify the inexact error, which takes in a bit of args. And I'm going to modify this so it prints line of the arguments. So it prints the following. I'm going to print a symbol, which is just going to be called truncate, I guess. And then we're going to print out the type of args of 1. And then we're going to print line args of 1. Go over here, Control D, run it one more time, and run this. Not what I meant to run. Run that. Knowing how the hardware works helped me a lot when programming anything, but it's not practical of me to think every time what 10 million transistors are going to turn into when this block of code executes. Right. I agree with that as well. I mean, there's a reason people like Python. There's a reason people like higher level languages. Okay. Trunc, int64, 4. This is actually exactly what I wanted to see. Right. So what I was trying to do was give the inexact error a set of arguments that works for that inexact error. That work for the inexact error. Actually, okay. So I might need to kind of go back to what this problem is. Some people might have forgotten. I start with being a I don't know what that is, but is the issue that int64 is not being rounded correctly to int32, or is the issue the error that is being thrown? So this is actually a very good question because it's not very clear as to what's happening here. So what's happening is the error that's being thrown allocates a tuple in order to throw the error. And we cannot allow it to allocate that tuple because we don't have this, because to do that on the GPU, you need to pre-allocate the space for that. And so it's not in the rounding. The rounding is actually fine. It's in the generation of the error of the rounding that the problem comes in. And so that's why it's kind of a bit, you know. So let's just try running in exact error. Okay. Yeah, this actually gets kind of a bit confusing. I'm just going to see if this actually runs. It's not going to, but I'm going to try to get it to run, and then we're going to try to figure out the next problem. And again, might be doing a bit of rubber duck debugging at this stage, because look, I'm deep into this now. I'm not saying people in chat are not going to be able to understand. What are the TIDs? So a TID is a thread ID. So in kernel logic, specifically for kernel abstractions and for GPU programming, what you do is you grab a thread ID, which is kind of an integer that represents which thread you're working on, and then you use that as your like I index or something through an array. This compiles to CUDA. Yeah, so it compiles down to CUDA. It also compiles onto the CPU. It compiles down to both. Right, so here's an issue that I'm having. Let me show you the kernel again. So what this does is a basic kernel. We have a TID, which is just going to be global linear. What I do is I actually run the event on the CPU first, just to make sure that version is working. And then what I do is I run it on the GPU after that. Right, and so again, just to kind of walk people through the process, here's what's kind of happening. And let me show you the actual error one more time, and just kind of walk through the whole thing again, because we kind of got sidetracked, and let's go back to it. So let me explain the full error from the start. So this is what happens when you run the code. First, I'm going to show just the CPU and show that it works with the CPU. So we're going to go here. Hey, Gawabunga, how are you? We're still working on that bug that came up a few days ago, and I'm sorry, I suck. Okay, I personally like that my job gives me a mix of high and low level, since I'm a rendering engineer, still in a junior position though. Oh, that sounds cool. Let's write this. Okay, so first what I'm going to do is Control D. I'm going to run Julia, and I'm going to run this code. This is going to specifically run the CPU version. I commented out the GPU version, okay? And we'll see that everything works. The compilation process works. Everything's fine. I hope, unless I really screw it up. Give me a second. And then we're going to run the GPU version, and I'm going to show you that error. Okay, everything compiled. I didn't have a test. This is just to make sure the compilation passes, and then we'll do the test afterwards. Okay, so now I'm going to comment back in the GPU block. And so this is compiling down to CUDA. What we've done is we've executed it so that we're running on the CUDA device with 256 threads. It compiles down to CUDA, but it uses OpenCL logic, so like ND range instead of grid size and stuff like that. Let's write this, and we're going to run include one more time, and this one should, I think, produce an error as it executes on the GPU. Give it just a second to precompile. And then we'll walk through that error, and I'll kind of show you where it is, where I'm pretty sure it is from a like just higher level perspective. I just looked it up, Julia, but I'm not sure what it is. Does it compete with MATLAB? No, it competes more with C++ and Julia than it does with, it competes more with C++ and Fortran than it does with MATLAB. In some sense, you can see it as a MATLAB competitor in that its syntax is like maybe a bit similar-esque in a way. I don't know why that's... Did I forget to write this? I don't know why that's passing. One second. Oh, I know why it's passing. Because I'm an idiot. I'm not converting anything. This is int32. Control D. All right. Let me do this again. One second. Oh, it's 600 now. Let's take a look. Ooh. Okay. I like that. Yeah, so we were thinking about a logo like this one as well. I think this one might be my favorite so far. Yeah, that one's also quite simple. Yeah, all of these are quite nice. What might be nice... Okay, so hear me out. This almost looks like a terminal, right? Maybe we could... Okay, I like that one because it looks like a terminal, but I also understand that maybe the lines are too much. Yeah, I quite like these. Yeah, they're quite nice. Can we post this on somewhere? Where should we post this? Let me put this on GitHub for now. Or on Discord for now. Here, algorithm archive. There, some more logos. They look quite nice. I think that one looks Sierpinski. Oh, maybe that's why I like it. Yeah, it does kind of look Sierpinski-y. Maybe that's what we want, like 3 Sierpinski triangles put together. I like the second and last. So this is this one and that one. That's probably fair. Yeah. But the hole in the A is hard to read. Yeah, here. I would have seen the letter A storing books within itself, like the one on the side, right? Wait. This one up here. Is that the one? I would have seen the letter A storing books within itself, like the one on the side rack. I missed something. So yeah, you do rendering without any real knowledge of oh, I didn't give you guys this link. Here, let me give you guys this link as well. It should be in chat. So yeah, you do rendering without a real knowledge of a GPU, but with the new API DX12 Vulkan, even just having a general understanding of how the GPU works and the low levels makes it a lot easier. I think it looks like, yeah, I think that's why I like that one. It does kind of look like Sierpinski. The A's look Sierpinski like the terminal, and terminal like, right. I like second and last, but not the hole in the A is hard to read. At Nick's fiance, yeah, no, they look really good. I'm a fan. I would have seen the letter A storing books within itself, like the one on the rack. It would be better with solid lines than outdated lines in the Sierpinski A one. Yes. I mean that in the sense that it's designed for like HPC applications and stuff, and I assume it makes it easier to do simulations. Right. Going back to Julia. So Julia is useful specifically for high performance computing, which means it's useful again, as a replacement for Fortran more than it is a replacement for MATLAB, in my opinion. People who use MATLAB just use MATLAB. They're not going to change. People who use Fortran have been looking for a replacement for a long time, and this is probably going to be a good replacement for that. And you know, it's going to replace C++ in that space as well, in my opinion. That's kind of who it's targeting. Okay, so I think I'm going to put here and just say, okay, these logos are great. Actually, I'm a big fan. Thank you so much for that. Should we, I guess we should put it to a vote. I guess we should, should we collect? MATLAB's pay to use, right? It is now. Wait, what do we mean? All right, let's just go ahead and say comment on there. Okay. Okay, so I really want to. I know this is going to sound kind of a bit. I don't know how it's going to sound, but I do want to go through this bug. So if you guys don't mind, I would like to. I'd like to kind of walk through it one more time and see if anybody else has any other ideas of how it could work. Because right now I'm lost, and I've been working on this for days now, and I genuinely have no idea how to go from where I'm at to where I want to go. Remember when you could buy professional software? Pepperidge Farms remembers? Oh yeah. No, Nick, this is great. Definitely interrupt with that. That was actually super cool. Again, tell your fiance that, like, honestly, they're super good. I think this one I quite like. I think for this one, some of them I might like kind of change a little bit. Like I might make the shadows a bit more evident that there's 3 A's in the background, because I actually quite liked that. This one I liked, but I can't quite explain there's something about it. And it might be that when I'm looking at this, it almost looks like this is a nose and this is a guy's mouth. I think that might be what's kind of putting me off. But I like it a lot because it does kind of give that like Sierpinski and terminal feel. Like that's what I like that one a lot. These guys I just like the A. I think that's fine. I think they're quite nice. This one, I like the terminal-esque feel to it, but like also, I'm thinking about like the shading isn't clear enough, right? You know what I mean? It looks like 3 Starfleet logos. And this one again is just clear, crisp. It's nice, you know? In fact, yeah, right. So that's the thing. So I think we should maybe put it to a vote and see what people like. But yeah, definitely. I really appreciate it. Thank you. I need to be very clear and just say like, I really do appreciate them. Like they look great. Okay. So let me just talk about this error for just a second. I'm going to execute this on the CPU for first. That was a sentence that just came out of my mouth. All right, let's try this again. So we're going to execute it on the CPU just to show that there are no errors. Julia, include minimum working example 2.jl. Give it a second. It should just precompile everything and work. Then we're going to show the GPU error, and I'm going to walk through what that error is. So there's CPU working just fine. Now we're going to comment in the GPU block. Okay, So this is where the error comes in. I think this will just show the error. And we'll walk through it, and I'll try to explain what's happening to the best of my abilities and to the best of my understanding. I might still be getting this wrong. And for the record, if anybody wants to follow this, please go to this PR here. There's more information here, and also in the linked issues. So here's the error. It still crashes. Oh, it definitely, yeah, it still crashes. So here we have throw inexact error of type int32, int64. Okay, so what's happening here is we have an unsupported call to Julia runtime JLF tuple. Now, if you look at this code, again, you're going to be asking yourself, where's the tuple? I don't understand. Where are we allocating a tuple? More than that, why do we have this unsupported call to JLF get field? Anyway, so that's what we have here. Let me show you where these are coming from. So we're going to go here and we're going to do an @edit of int32 of 10 or something. So this is converting a int64 to an int32. I'm going to go to line 624 here, which is the checked truncate signed integer. So what this is going to do is it's going to make sure that the integer int64 that we're reading in is going to make sure that it is like able to fit into an int32. So we're 64 to 32, so we have to truncate it, right? So this is calling equation int equal int. I actually don't know what this is doing, but I think what it's doing is making sure that the two numbers are the same, that x, which is what we're going from, and then back. I don't know why it's called back, but I think it's making sure that the two are equal, and then it does or throw inexact error. So let's go there to 602. And here we see throw inexact error of f symbol. And here you see the symbol is down here as just like trunk. And I'll show you that in action in just a second. Type t, which is going to be of type int32, which is trying to go 2, and then value v, which is going to be like 1, 2, 4, whatever it's trying to convert. And here is the tuple. It goes right there, this guy right here. This is the thing that is allocating, and this is the thing that you can't allocate on the GPU without some sort of memory or something that you're pre-allocating for it. So because we have this guy here, everything kind of fails. That is not good. You see that it goes here, no inline meta, and then throw. So this allocation is not allowed on the GPU. Now, here's the part that gets really tricky. What I tried doing next is I tried specifically changing the inexact error. So here what I'm going to do is I'm going to overdub the inexact error with something that just prints out the arguments. So I'm going to change it to print line args. 1 second. Here, we're going to write that, go over here, Control D, run Julia again, and run it one more time. Oops, sorry. Here, and then we'll see that error as well. I'll take a look at the link in just a second. Let's see. Quick question. This is actually a good point. Let me take a look at the project here. I've been doing a really bad job with the master overview, and let me take a look at this as well while we're waiting on the error message. Let's go here. Oh, okay. Yeah, that's not bad. However, so this would be like a combination of... Can I just paste this directly? Fix to allow, convert to int. Where are we? Algorithm archive. Galbomka said, let's see. Did I spell it right? Galabomga 0 from Twitch said something like this. I'm just pasting that in here so we have it there. And now let's go here as well. Algorithm archive number 11. There. Okay, so with this, the convolution chapter is almost done. So it's going to be in the crappy chapters. Oh, we're missing convolutions, add figures describing... No, this stuff for the convolutions is still not done yet, unfortunately. But this, oh, this is done. Maybe? Wait, is it done? we're still missing some of the stuff for convolutions. We're missing the FFT-based stuff for convolutions. So I don't think we can put it in there. No, this is great. Thank you so much for mentioning that. So specifically with convolutions, I think what I should do is I should move over. Can you show the values you're trying to convert? Yeah, so right now it's 1 and 4. So I just printed those. So here we have printed the value 4 and printed the value 1, which was us printing the arguments that we're trying to convert. So TID is going to be a set of threads, because this one in particular was running on the CPU. It only had 4 threads, so it could only be 1, 2, 3, or 4. So we're just trying to convert those, which are inherently int64 values, onto int32. And you're right. So what I should do is I should move this to in progress, kind of. And there's a few things, sub convolutions that we're putting in. Okay. So, right, let's take a look here. So here we see further problems, right? So what I did is I made it so all of the throw inexact errors will turn into print line statements that specifically print the arguments, right? And the args here are 4 and 1. Now this is weird because again, if you go into the throw the error, let me go to @edit here and let's go to 624. The only time we're calling the throw inexact error is if we have a symbol, a to, and a from. A symbol, a to, and a, I guess a from or whatever. So the only time we can call this error in this backtrace is if we have these arguments already available, right? So the problem here is that we don't have these arguments already available. Because we're overdubbing it at this stage, it's reading the args as the args of this guy, not the args of... Oh, maybe not even that. It's seeing this as the args. Interesting. It's seeing the args of the function 2 int 32. So let's go up to int 32. So it's seeing these args here. Where are we? Int 8, int 64. Wait, let me just do this one more time. It's seeing these args. So 2 int 64 of x. It's only seeing x for some reason. I don't know why it's not recursing one level deeper, but it's only seeing x. So then the next problem is that because we can only see the 1 and the 4 here, the inexact errors are failing because there aren't enough arguments. So then I thought, okay, there aren't enough arguments for it. Let's just simulate the fact that if we did have enough arguments, what would happen? And so what I did there is I said, okay, inexact error of type trunc, which I misspelled, which is fine, it doesn't matter. It's just a symbol for the error message. And then we say type of args1, args1. Now these are the wrong values. We don't want to type int64 in there. We want to type int32, but fine, fair enough, whatever. Just kind of get them in there, make it work. And then we run into one further error, which I don't understand at all, which is a nested task error. Method error, no method matching star of nothing, nothing. No idea where this comes from. I don't even understand where the nothing, nothing comes from. And I don't know, I'm really lost here. So this is where I'm at. I'm sorry I did such a bad job describing this, but this is what I'm trying to figure out. By the way, latchm_, thank you so much for following. Really appreciate it. Let me get a quick sip of water. What happens if you convert twice? Yes, so I tried that as well. Let me show that off. I will go back to the base. I'll go back here. So we're going to go back to the base kernel abstractions without the stuff that I was just adding in. I assume that you look through the 3 closest candidates. Well, right, except that we don't... Where's the multiplication symbol? I don't know where the multiplication symbol is. That's what I don't understand. My fundamental issue here is that I never told it to multiply anything. So that's where I'm a bit lost. Suki the Dwagon. Ah, hello. How are you? Okay, so if we convert, right, it's in operators.jl, but I don't know where in my code the multiplication comes from. Is the problem? This is Arch Linux with OpenBox. A conversion of one to the other could run multiplication. Oh, okay, I see. So you're saying in the truncate. Okay, well, let's do this then. So are you asking for a convert from maybe something like this? So if we do int64 of this. So we converted from int32 to int64 or something. Yeah, let's actually take a look there, because there could be a multiply in the truncate. To be fair, it's not running truncate at all. It's not running truncate at all, but it's compiling that. int64 to float to int32 or something. Yeah, so yeah, I've done this test before. int32, so it's int64 to float. This conversion is actually going to be fine, and I will show that. So float 64. I will show that the float conversion is fine. Here first. Quit. Julia, I should just include, and then I'll convert that to int32 after that. And it's going to be running my first ever Arch install. Oh, super cool. So a while ago, maybe a year or two ago, we actually did an Arch install speed run where we were able to get the install down to like 2, well, I think it was 3 minutes in the end. And I think someone else, 1 second. I'm an idiot. That's the convert. Okay. Here, I'm showing that the float works, and then I'll show that the conversion from float to int doesn't. Where in kernel abstractions is the conversion supposed to occur? I will show you. Give me a second. By the way, thank you guys so much for this. Let's go to kernel abstractions here. So the place where you create the GPU library is going to be in source macros, and then GPU transform line 80, I believe. This line. This is the line that breaks. Let me go ahead and copy line. So that's where that is. I'll take a look at the multiplication. Here we showed that floating works. So now let's go into int64 from here, just to show that it also breaks within int64 convert. Okay, so let's go here, Control D, Julia, and then we're going to run include mwe2.jl. What do we have here? Now that I think of it, Julia sounds interesting, and sounds like an interesting way to get into programming, convert algorithms into code, and figure out ways to optimize said algorithms, or figure out an analog that's less expensive. Right. It's all awesome, but can you make a Sudoku solver? Interestingly enough, that's actually on the list of things to do in the near future. Turns out that if you're going to, there's a proposal in electrical engineering to basically send the internet along power lines. The problem comes in error correction, but one way to do error correction is with something called the Newton squares, I believe, which are essentially a higher dimensional version of Sudoku. And so in solving this regularly, you can actually solve the error correction problem, blah, blah, blah. Anyway, it's a research project that's coming up. It's awesome, but yeah, I'm going to be doing my first Arch install. Apparently, I need a custom kernel for the laptop. I can't even install Sudoku the analog way. Oh, neither can I. You need algorithms for this. Buoyant Flamboyant, thank you so much for following. Really appreciate it. So 4D Sudoku, ND Sudoku, not just 4. I say higher dimensions, but it's not. It depends on how you want to do it. So like it's n dimensional, but also of size n. It has constraints similar to Sudoku. So it is an easy way to grasp it is that it's like Sudoku, is what I should say. Okay, so now let me take a look at the trunk and see if there's a multiplication in the truncate function. So we're going to go here to add edit. I mean the wetware computer way. Oh, what is a wetware computer? Okay, so let me take a look at the trunk function. Trunk here. So we have trunk int. Let me just go to 624. Let me take a look at these functions. So you have sextint and trunkint. Here, there. Oh, these might be intrinsic functions. Oh, they are. They're from intrinsics. Oh, we have to look at the Julia source code for this. Or is it in... No, we have to go to Julia source code. Okay, Julia, GitHub. Higher dimensions could be fun too, like 4D or 5D chess. Right. Wetware computer is equal to brain. Oh, that's fair. Yeah. The computer between your ears. To be fair, but it's not that good of a computer. Okay, so we're gonna do source. Oh, where is this, Julia? We want to go to. It has to be under source. Then it has to be under. I don't know. Where is this gonna be? Where are the intrinsics? Let's actually look for it. So trunk int in Julia. Now let's look for it. Okay. Floating point convert to float in int. Math.jl. Let me look this up in Google. The brain has insane speed and storage, but everything is terribly optimized. Yeah, that's true. Base.trunc int. The brain might not have as high of a clock speed, but compared to a CPU, things it does in one cycle are ridiculous. Right. So actually, we had one of my initial projects with OIST was creating an analog electronic brain, and that's actually on the list of things that I want to do again. What was I looking for? Trunc int? Trunc int. Okay, so this does core.intrinsics.trunc int. Can I call that in my terminal? Core.intrinsics. Maybe. Can I do core.boot? Oh, dang. Intrinsics. Dot trunc int. It's here. So can I do @edit? This guy? And see where it's at? Trunc int of pi. Of any methods of core.intrinsics dot trunc int built-in functions with no methods. Wonderful. Let's see. This is such a fundamental operation. I'm surprised other people run into it too. Right. It's a fundamental operation with specifically kernel abstractions, and there are currently like 4 issues available, like up on kernel abstractions right now for this issue. So yeah, it's that was the thing with the PR. Let's go here. At least 2 of these guys have had issues, and I also had a similar issue. And so it's like a bunch of masked things. I've seen like 4 different issues all on this one thing, but no one knows how to solve it. And the only person that can solve it right now is just super busy. And so I was trying to get some weight off of his shoulders, so like we could kind of start working on this. I don't know. Like, again, like I said, I'm completely lost with this. If anybody has any idea how to solve it, like I'm all ears. So like if you guys have an idea of what to do, just like shoot it at me and I'm going to try it, because I'm lost, like completely lost. So this is why I'm looking at the trunc int function to see. I think this is actually in C++. I think that function is actually in C++. And I think, oh, I see. So it's for a floating point number and then of type any. Check the power operation that could be calling the multiply function. The power operation. So why are we calling power? I only rate spaghetti. Probably can't really help. That's fair. I think most people rate spaghetti. That's how it goes, right? Okay. Wait, I'm trying to let me find one of these functions first. So @edit int3210, and we're gonna look for 624. I'm looking for sext int is what I'm looking for. To convert from one to the other, you raise to the power of 2. Of course, you're bit shifting, right? Yeah. Let me try to find trunc int, and then let me try to find. Yes, let me try to find trunc int, and then we'll see if that does the power. So we're gonna do core.edit. Let's try it. Core.intrinsics .trunc int, and we're going to take 10, and then we're going to take int 32. Trunc int value is not a primitive type. Okay, perfect. Let me just try to find trunc int in Julia. I can't find it. It's somewhere. Okay. Trunc int Julia G. Discourse, GitHub, boot.jl, intrinsics.jl. That's what I'm looking for. And let's look for trunc int, which calls core.intrinsic trunc int. Okay, trunc int 24x. Okay, so I did it backwards. So let's do int 3210. Okay, and if we do something like this, I don't know how that worked, but it did something. So now I want to edit this. Argument error. Argument is not a generic function. Perfect. So this is in the, thanks, Amaris. So this is a issue with the C++ code. Great. That's what I wanted to see. So Julia, where do they keep that? Source? stdlib maybe? Oh no. I know what I'm gonna do. You guys are gonna hate this, but this is what I'm gonna do, and you guys are gonna have to deal with it. We're gonna go into my Julia directory, cd builds Julia, and now we're gonna do grep-rl, and we're gonna look for trunk int. I misspelled trunk. Yes, I understand. Okay, so here's where it could be. It's going to be in source intrinsics.cpp. So I'm going to make this a bit bigger. Julia source. And then we're going to, nope, no. Intrinsics.cpp. Intrinsics.cpp. Let me make it bigger. Oh, bigger. So everyone can see it. Oh, maybe not that big. Okay, whatever, it's fine. And now we're going to look for trunk int. How are you guys so much better than I am? Line 134 in intrinsics. 134. 134. Generic cast. Generic cast of context instruction trunk. Okay, so generic cast. Generic cast. Okay. Oh man. Want to become famous? Buy followers and viewers on bigfollows.com. No thanks, man. Appreciate it though. Let's see. How do I do this again? I'm really bad at this. Should I block or should I report? What's actually the appropriate thing to do here? Probably report, right? Right? Report. All right, let's just report. Threats, hate speech, evading, block, ban, spam. Perfect. I think there's a bot account. Attempts to scam other communities, sending malicious links, sending repeating messages. Bot account probably. Next. Links. Oh geez, they make this so hard. Yeah, okay, you're right. Let's just screw it. Let's just ban them from chat, I guess. Yeah, okay. Whatever. You're right. Because someone's account could have been hacked and I didn't think about that. Okay. Right, because the entire source code of Twitch was just leaked, so yeah, it's very likely that someone could have been hacked. Okay, so JLCGValT. Oh no, just come on, please. Am I in the wrong file? I'm in on intrinsics.cpp, but maybe you meant intrinsics.jl. Oh, let's see. The person that probably forgot to enable two-factor authentication. Yeah, to be fair, two-factor authentication in Twitch is a huge pain. CPP. Okay, so you said line 134. Okay, so what is this doing? Well, line 134, static value, uint. Oh no, these names. So type, get primitive in bits. Type 2 value x. Okay, I think you're right. I think you're right in saying that. I think you're right in saying that for some reason, cassette is not grabbing. I think you're right in that somehow, in changing the inexact error, to a print statement. Okay, so essentially what we're trying to guess is that changing the inexact error to a print statement somehow changed the AST such that, no, maybe it's a convert. I'm lost. So wait, what are we trying to do? So we're trying to figure out why we're multiplying two print statements. That's what we're trying to figure out. Why is print times print even in there? That's the question. To which I have no answer. I genuinely have no idea. What we tried to do is we tried to change the inexact error to a print statement to print out what we're supposed to get, and in changing it to a print statement, all of a sudden we're multiplying two print statements, when we know before we changed the inexact error, we were definitely not multiplying two inexact errors, right? Okay. If anybody wants to test this out on their own machine, kind of mess around with it, all I did was downloaded the latest copy of kernel abstractions, and I modified a few lines in compiler.jl, and then basically I just ran dev of my local kernel abstractions build, and that allows for me to kind of switch out the different kernel abstractions versions that we're messing around with, in case anybody wants to try it for themselves. To be fair, what I was trying to do here was basically just copy what we had up here for inline overdub type of base.math.throw exception exponential domain error. I tried to make these cases available for the inexact error as well, but it doesn't seem to be working. Anonymous Cheer, thank you so much for the bit. Really appreciate it. So, yeah. Yeah. This is where I'm done. I genuinely don't know. I've been looking at this nonstop for the past 3 days, and I have found no solutions. I've been doing short streams because I've been working on this for 2 hours on stream and then realized I'm massively over my head. What? Massive? It is massively over my head. So that I've had no idea what to do, and this is the full problem. This is as far as I've gotten in 3 days. I know it sounds like it's not much, but this is stuff I don't know much about. So, I'm not trying to say, oh wow, I'm so good at figuring this stuff out. I'm trying to say the opposite. I don't know where I'm going. So, okay. We tried a bunch of different things. Let me scroll up again. So, what is this error that we got here? This error was when we tried to convert. If you change to 600, yeah, I'll take a look. Is it only Julia plus kernel abstractions? Also, can you enable kernel debugging? I had to do that in JavaScript. I don't know. I don't know what exactly we can do there. We can set a compile flag, so that we send more errors out on the GPU. So the GPU debugging. Let me see. What do we have? Here. No. Where is 600? Where are we? I've lost it. Okay. Oh, okay. Wait, was this edited? Oh, down here. I see. Oh, yeah, that one's cleaner. I like that one. Yes. Nice. That one I quite like. Yeah. Let's see. So I quite like that one, actually. I like how the A's are kind of closer. It creates like the diamond shape. I kind of actually like that diamond shape in there. Yeah. Let's see what we need to do about that one. Yeah. I like it. I don't know why, but it reminds me of that. Wait. I don't know why, but it reminds me of 3 Arch Linuxes stacked on top of each other. The 1A still looks like a guy with a nose and a mustache. To be fair, a little bit. In fact, you could say, here's the guy, and he's wearing like a poncho now. But, right, I think we're getting there. I think maybe what we'd want to do... Anyway, let me work on it a little bit on my own as well, and maybe we could figure out something, because I think actually this is pretty close to what we might want. But also... yeah, let's see what other people are thinking as well. I do like this design as well with the shadows in the background. I think that's quite nice. I don't know. I don't know the best solution, but these are quite nice. Thank you so much. I really appreciate it. Yeah. Now I'm thinking about logos. See, Suki, thank you so much for coming in. Have a wonderful evening or morning or whatever time it is your time. Okay. What do we say? Okay. So with the error, I'm lost. I don't know what we should do with it. And I don't know if anybody has any ideas. Yeah, I really don't know. But what I do know is that the error... Yeah, I don't know. I genuinely don't know. So this is where I ended as well today, saying I'm lost. I have no idea where to go. Maybe. Doc backtraces. Report analyzing crashes, seg faults during boot startup, errors during Julia startup, version environment, seg faults during boot startup, seg faults, errors, strace Julia. Is that useful? Strace? Oh, this errors during Julia startup, right? Glossary. Yeah, that's what I want. Perfect. GDB. I could just do GDB. Call jail object. I have the wrong one on the clipboard. That's fair. Call. Oh, I see. You're doing GDB for a C call. Okay, that's fair. Useful Julia variable for inspecting. Useful Julia functions for introspecting variables. Inserting breakpoints for inspection from GDB. Break jail breakpoint. Right. Insert breakpoints upon certain conditions. Calling a particular method. Dealing with signals. Okay. I mean, we could just use GDB. I mean, that's something we could do. Debugging during Julia's build process. I don't think we need these. Debugging pre-compilation errors. Mozilla record and replay framework. Are we a pre-compilation error? I don't think so. You have to modify the Julia source to trace some of these things. Right. We have the Julia source. We can update it. Let me make this smaller because I'm having trouble reading it. Okay. Call jail. So within GDB, any JL value type object, JL value T object can be displayed using the following. The objects will be displayed in the Julia session, not in the GDB session. This is a useful way to discover the types and values of objects being manipulated by Julia's C code. Okay, fair enough. Let's see, we have apply generic, useful Julia functions for introspecting those variables. Let's do dump, break, JL breakpoint. In your GDB session, you can set a breakpoint. Now, okay. Are we... See void Goodreads COVID for a second? Oh. But let's see. Wait, it's going deep to find where to start digging. Right. 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 Because in all likelihood, this is something we need to fix on the kernel abstractions level. In all likelihood. In that it's probably that. So the good news is when we try to update the inexact error, it does catch the correct error. It is printing instead of like it's catching the error. Like it knows that we're trying to fix that error in particular, right? So the first part of this cassette overdub thing, where it's cassette overdub type of inexact error, that's calling it right. The problem is the second one where we put it onto a throw or something, that's not working. And I don't know why that's the case. ZXML, we are basically trying to figure out how to convert to an int64 on the GPU. Specifically on the GPU using a library called kernel abstractions, which allows for us to write code that works on both the CPU and GPU. We've been through the stack trace, and apparently what happens is in the call to throwing an inexact error, which is a check to make sure that you actually can cast it onto an integer value, that error allocates a tuple, and you're not allowed to allocate the tuple on GPU hardware. So it works on the CPU, but it doesn't work on the GPU. The issue with this is that it comes at the compilation, comes like into the process when we're overdubbing or basically dispatching or creating functions from the... I'm doing a very bad job of describing this. This code that we're writing right here is code that has been written to extend to either the CPU or GPU. When we're dispatching it onto the GPU, i.e. creating code that works on the GPU, it doesn't like the fact that we have to basically allocate a tuple for the call to the inexact error. That's the problem. I think. I'm pretty sure. So then what we tried to do is we tried to take the thing that is doing the overdubbing, which is called cassette, and we tried to change the inexact error so it called something else, like print line. And in doing this, we found that not only is it, printing line at the wrong time, but it's also not having the right arguments for the inexact error. So even though we're replacing the inexact error, the arguments are incorrect. And somehow this messes something else up down the pipeline, which basically makes it so it looks like we're multiplying two errors together. And I don't know where that's coming from. I think Nick might be right in saying that this might be that there's like a power used to do the truncation from int64 to int32. So that could be the issue here. But then how, I guess my stupid question here is, if that's the case, if the case is that we're doing some sort of bit shift operator, which is going to be just a multiply by 2, which is a weird way to do a bit shift operator, how would we ever get to the stage where we're bit shifting two inexact errors? Ah, man, confusing. It's super confusing. But actually, in doing this, we made a little bit of progress. I think we figured out the args here is not exactly what. Yeah, I think we figured out where the args are coming from. They're coming from the kernel call, not from the they're coming from the kernel call, not from the inexact error. So this gives us some idea that we are like going through the AST in a very weird way. I don't know, like it's honestly quite. This is not stuff that I know how to do super well. It's stuff that I should maybe potentially know, but man, it's tough. So anyway, this is what I've been banging my head against for the past few days. I might still try to bang my head against it for another 10 minutes or so here on stream, but then I might call it from there and just say, it's the end of stream for today, and I'm just going to keep banging my head against it outside of stream. Let me go back to the error that we have here in the, here. Hey Meowcat, how are you? So let's go to, I have so many of these guys up. Let me just delete all of them. None of them matter anymore. Okay, we're gonna go to kernel abstractions, here, and let's go to this one, and then we're gonna go to pull requests, and then this one. Okay, there was a bit that we learned here in that no method matching inexact error of int64. So here what I'm going to say is that when we changed it to print, what happened when we changed it to print? Yeah, let me actually change it to print and show that error as well here, just because that might enlighten someone who knows more than I do about this. So let's show that error. Control C. Control D, Julia, and we're gonna run this guy, and I'm gonna go ahead and start writing this. As another important note here, changing the inexact error to a print, maybe print line. And let me put that here. So we're doing compiler dev. I mean, a little bit, unfortunately. I mean, maybe fortunately. I don't know. I don't know what people are into. Here. This, that. Sorry, give me a second. That. Basically, for some reason, only works on 2 threads. Always 1 and 4, before saying that we are multiplying 2 print statements. I think the error above is because args for cassette is for some reason Because args is grabbing the arguments for the toInt32 call. 1 second. Like, this is the thing. I don't know if anyone can actually solve this issue right now. Instead of the throw inexact error. 1 second. Call. Okay, I think the error above is because args is grabbing the arguments for the toInt32 call for this call instead of the throw inexact error call. Here's the error messages for when we swap it out with a print. It'll be ranked as not important and will be fixed in 3 years. Well, okay, you'd say it's not important, but also we have at least 4 issues for this particular problem, right? And so that's why it's like, hey, look, this probably should be solved. Like, people are definitely, like, you know, mentioning this. All right, let's put this down. All right, and just get the error message down. It's a bit of a long one. Oh, no, it's not so long. Let's go here, and I'm just gonna grab this whole guy. Do you like to say my Julia version is? Not now, because my Julia version is all Julia versions. I mean, I tried it on Julia Dev. I did it on the most recent Git branch. I did it on Julia 1.6, which is a version that's out. Normally, I've done it on Julia 1.4, and I also told the primary maintainer that I've tried this on all different Julia versions, and it all provides the same errors. It's not like I'm, you know, dotting all my I's and crossing all my T's, but I'm being a bit, you know, persnickety with this. All right, paste this down here. 1 second. Oh, dang it. Auto indent is just the worst thing anyone has ever invented. Oh, are you kidding me? Oh, come on. Okay. No, auto indent again. Okay, good. Crap. What's the last line? 2. So we want to grab this guy. There. Okay, that should be right. I think I need to, you know, do that. Okay, comment. Okay, that's that error there. As another important note, changing the inexact error to a print, something like this, for some reason it only works with 2 threads, and saying that before saying that we're multiplying 2 print statements. Right, and it's a nested task error is also important to note here. I really, oh, I guess here I need to mention, at edit. So I also looked up the nested task errors. Oh, oops. That's my bad. Here. Task errors. Julia. I guess here. And here maybe. I believe fix this in main branch where I can't reproduce the error. Okay, let's go here. And I found this guy, which was somewhat relevant. 1 second. Where are we? Here. Since the error is a nested task error, let's do, I guess I'll scroll down a little bit and put it down here. Since the task is a nested task error, I did try this on the latest Julia version from GitHub to make sure that it wasn't somehow a catch with this issue. Update comment. Hey, Flap Flap Octopus, how are you? I hope you're having a great day. Okay, okay, so what do I do from here? I don't know. I genuinely don't know. Doing well on yourself? I'm okay. I mean, look, I've been banging my head against this bug, which is like a fundamental problem with the, you know, Julia compiling ecosystem. I think. Would you say Julia is a mature language? it really depends on what you could say you call mature, right? Is it as mature as Python? Yeah, I would say so. Does it have, do the libraries that I need to work with, like for example, I'm working with a very specific library here that, take a single code base and compile it to either the CPU or GPU. That's that's an issue, right? kubectl, actually, what? Yeah, anyway. I know very little about coding, mostly MATLAB. That's fair. So Julia is a programming language that has relatively simple syntax like Python, but the speed of C or Fortran or something like that. It's primarily used in scientific computing for high-performance computing applications and stuff like that. What I'm currently working on is an application with kernel abstractions, which is a way for us to write a single bit of code that executes on both the CPU and GPU. And in particular, we're running into a weird situation where when we try to recast something onto an integer on GPU architecture, it for some reason doesn't work. That's what we're running into. So I'm basically trying to tackle this bug from as many different places as I can, with the hope that we can kind of figure out the problem together, me and whoever the maintainer of kernel abstractions is, who is actually one of my close friends. We roomed together for a while. As mature as Python, like a 30-year-old language, right? Okay, I guess that's a question. What does software maturity actually mean? And for that, I don't really know if I have a good answer. When I think of maturity, my gut instinct is, when I think of a mature language, I think of it as a language that doesn't have weird quirks to it. Like when I code in Julia, when I code in Python, does it act like how I expect it to act? Or is there some weird quirk that's specific to Python or specific to Julia that, I have to work around because that language is weird in this way or that way, right? Every language has that, right? C has this, Fortran has this, every single language has that. The question is, when I'm coding in that language, does it feel like I got to work around some weird thing as part of the language infrastructure? The problem with Python and actually C++ for that matter, is that they've existed for so long and they've worked through so many eras of programming, that, they almost feel immature, because you get to the point where it's I don't really even know how to write code in this language anymore because it has so many different extensions and all this kind of stuff. Whereas Julia at least feels like it knows what it's supposed to do. I'm doing something really weird here with a bit of the code base that most people aren't going to touch. For everyone else, Julia I think would be quite mature. For me, in my specific use case, there isn't really a language that is mature for this. There are a few extensions to C++ I could use. There's maybe some Python stuff I could try, but ultimately this stuff is kind of cutting edge, and there isn't really a language that is mature for what I want it to be. You spoke Japanese, and I cannot read it. Let me double check to see what you just said. I'm so sorry. You said, if I just knew the kanji. No, give me, no, give me, don't give me that. I want the pronunciation here. I want it without the kanji. Oh, come on, not Google Translate. Give it to me without the kanji. Not you, Google Translate. Here. No, just, I want to know what this is. Kareteiru no de areba. You need to go to full translate? Okay. No. Give it, just no kanji. That's it. I can only read, retteru no de areba, sore, mitemasu? Arigatou gozaimasu. Kawarete, kawa. Must be broken. Kawareteiru no, wait. 壊れているのであれば、それ直す。そうかな。I see. Yo, I only know about those programs because I had to do an assignment in criminal justice regarding password. Wait, what programs? Regarding password security and internet security in general. It's written, only Link can defeat Ganon. You're translating from Spanish? Thanks for that. Google is too mature for that. That's fair. I need to get back to learning Japanese. Honestly, I've been trying to learn Japanese and I suck at Japanese. I mean, look, my wife is Japanese. Her whole family is Japanese. I can't speak to pretty much anyone in her family. There's like a few people I can't speak to. Obviously, I can speak to her as well. But I do need to learn more. Like, I feel like it's kind of on me to be able to talk to them, you know? Okay, here's what I'm going to do, guys. I would like to keep going with this. I'm busy learning German, so I'm going to wait with another language. Totally fair. I mean, like, I should also be learning Spanish, considering I'm in Barcelona. I'm amazed by how you can work on solving these issues with the way you jump from subject to subject during these streams. Sorry, I know I jump too much, and I know that a lot of people have mentioned, at least viewers have mentioned, that I jump too much, and that it's not, like, it's hard to keep track of everything because I context switch so much. Let's see, learning from German? I thought Leos does. Wait, no, I don't know German at all. Hallo, Alice stabil bei der... I don't know what you just said. I'm so sorry. I can't speak any German. I'm so sorry. I'm living in a non-German. I'm living as non-German in German. So kind of useful. What is your level of Japanese? Can you call the doctor in Japanese and schedule an appointment? I can call my wife to call a Japanese doctor and schedule an appointment. Passwords that ones are easy to crack and ones that are hard to crack. Oh yeah, cool. As far as that's concerned, I mean, I did at some time, I was quite interested in doing, like, you know, basic penetration testing and stuff like that. I was thinking about even doing it on stream, maybe going through like the certified ethical hacker exam and stuff like this, but I never did it. Luckily, knowing Dutch is helping me with German. Your doctor wife? Well, no, my wife can call the doctor. Both of us have PhDs, but we're not that type of doctor. Okay. So what I might do for now is I might go ahead and call it for today, knowing that these are the errors that we're coming across, and like, I know, look, I basically just, I've been trying to figure out this error for a while, and I'm just kind of, not stressed, but I'm just trying to show it to you guys. This is the problem. This is the problem that we've had. C Flynn 46, thank you so much for following. Really appreciate it. I just came in. I'm so sorry, Melcat. I've been trying to do longer streams, but I've just been failing miserably at it. I've been streaming for 3 hours and 6 minutes right now, which is, I think, a good time to just say, you know, my brain's fried. Let's just kind of go, you know, and just annotate as much as we can error-wise and just say, this is where we're at, you know. It would be nice to look at debug, but no NVIDIA GPU and Google Colab is slow. Right. I mean, debugging on the GPU is just such a pain. Doctor for healing fractals. Hopefully we'll get back to fractals soon. Did you figure what is quote? What is quote in the in kernel abstractions? Like, what does quote mean in Julia? Is that the question? Does Colab run on Julia? So quote is a like, this is a quote, x plus x. That's a quote. So you can do like I think eval this should work. No, wait. It needs to be it's an expression. A quote is an expression. So it is like a function expression. So this x plus x is, I think that would be considered, you can put that into a quote, and then we say x equals 1, and we eval, well, let's do expr is going to be equal to the following, x plus x, for example, and then we eval expr, we'll get 2. So it's essentially a way for you to write this expressional syntax. Interesting, the last time I checked, there was only a Python backend. Python front end. Yeah, I know nothing about this, unfortunately. Yeah. Okay, so this is, I'm going to keep looking at this a bit longer. Yeah, you're talking about quote. Right, exactly. That's what this does. So if I do quote x plus x end, that gives me exactly this, which is REPL 2 x plus x. I think I can say q. I think I can do this. Q is equal to quote. And if I do q again, it should be, yeah, quote. I should be able to eval q, I think. Yeah. So it's the same thing. So it's a way to create more verbose expressions than the syntax that I just created before. So it's basically modifying Julia from the abstract syntax tree level. So that's why in line 80 of kernel abstractions. Let's just go there. Oh, come on, I cannot type at all. Let's go. Kernel abstractions. There we go. And then we go to here. And we go to source and macros. And then we go to 80 here. So the question why quote came up is because if we go in here, here we have this body is equal to quote, a valid index, return nothing. This is like common in Lisp, except that it is easier to build an AST in Lisp. That's probably fair. So theoretically, the Julia should be faster than Python. So theoretically, not theoretically, the benchmarks show that Julia is way faster than Python. However, the big catch here is that every time people do Julia benchmarks, they run it once to do all the pre-compilation steps, and then they run it one more time to get actually the benchmarks, right? Because Julia will do a compilation step on the first run, and then it doesn't have to do that afterwards. Nowadays, there are ways to go about to go around the compilation a bit easier. Like there's like a flag that you can run, like limited compile. I don't remember what it is, which will partially compile things into binary faster. So there's that as well. But for the most part, Julia should be relatively fast compared to Python. So the actual error message in kernel abstractions is actually coming from here. And it's good actually that you mentioned the quote stuff, because I didn't actually explain this very well. So what's happening is when we're transforming it onto something that can run on the GPU, one second. Essentially what we're doing is we're pulling out the constant arguments. That's what this is doing here. And essentially the way this works is it goes through each argument that you're reading into the kernel, and it asks, basically there's a binary set that comes in that says 0, 1, 0, 1, 0, 1, where 0 means it's not a constant argument, 1 means it is a constant argument. And here we're saying we're pushing onto let constant arguments whether we need to constify that, whether we need to turn it into a constant. Now, constants are important on the GPU because like I said before, dynamically allocating memory is really annoying. You have to make sure you've pre-allocated the memory. So that's why everything needs to be sent in as a constant. Then we push first on the arguments and the context. This is just pushing the outer argument, I believe, of the kernel abstractions kernel in there. So this means like the kernel name and its arguments. And then what you do is you say bodies quote, and you say if valid index context. These I think are cassette specific calls. And then we say def body. And what this is doing is it's putting the body of the function into a quote that can then be executed later. And then it returns nothing. And then we say def body is equal to expr let, and this is stuff that I'm a bit confused about, let, which basically puts it into a let block, I believe, to make it so it's all executed outside of the global scope. And then it's expr block let constant arguments body. And so here we have expr block let constant arguments, and I believe that's this guy up here, which is a set of arguments that we've had. I don't know what the block does, but essentially the reason the quote comes in here is because we're trying to build an expression that compiles on the GPU. There's a similar case down here which does it for the CPU, but this one's working, so we're only interested in the GPU case. So that's that, as much as I know about that. And again, I might be wrong, but this is the best I can gather. Yeah. Okay, so again, I think this is a decent enough place to stop for now. We've kind of at least talked about what the error is, and where we can go from there. I didn't like Julia errors. Oh, to be fair, the errors that we're getting from kernel abstractions are really messy, and it's specifically a problem with kernel abstractions. Julia errors are also a little bit annoying, but the kernel abstraction errors are another level of annoying because you're writing code that, again, can execute to either GPU or CPU, and so you get an error message that's calling like so many layers of abstraction down until you eventually get to the case where you're at the actual error, and it's not even clear where that error is in the code. It's a real big pain in the butt. But on the other hand, being able to write flexible code in that way is quite nice, and it means that you don't have to write both CPU and GPU code. You can write one kernel that executes to both. However, I'm running into the case where I feel like maybe I should just write two separate kernels. It would have been so much faster had I just done that. I was just really trying to tackle the kernel abstractions problem and go from there. I don't know, guys. Like, I've been thinking about this a lot. this is stuff that I'm actually quite interested in, but like I've never made like YouTube videos about this. This is all stuff that's always lived on the Twitch stream, and I've been wondering, maybe is it worth like making videos on this kind of stuff, being like, hey, this is how the whole thing has worked. This is a problem that I ran into last week. It's super complicated and really annoying to show, but maybe people would be into that. I don't know. I haven't decided whether that's a good idea to put on YouTube or not. But I will leave it here. Let me see who's live and who we want to raid at the end of stream. We have Anthony Writes Code. We have Cosmo Quest X. We've got Lana Lux. Anybody that you want to raid? Is there anybody live that you might want to watch at the end of stream? I'm happy to give someone new a go. I actually don't know. Like, I used to have a good list of people that were live at the end of my stream back in my other time zone, but now that I'm in a new time zone and I kind of end at weird times, I don't really know who's live and who's good to raid. So if you have someone live that you want me to raid, let me know. And of course, everything that I just showed you can be found here. So here's this. It has links to all the different issues and all that kind of stuff, error messages, everything. If you have any ideas, just post it on there. I'm really, really wanting to get this solved. At this point, I've wasted. It's a bit of a sunk cost fallacy. I've spent too much time on this, and I'm just slowly but surely trying to figure out more and more solutions to it. So. Okay, I'm not seeing anyone tell me to raid anybody, so maybe we do. What is Anthony Writes Code doing? Open source Python programming? Sure, let's do Anthony Writes Code. That sounds fun. So we're gonna go ahead and start that raid. Raid Anthony. I don't want to mess with it, but I didn't quite understand how the ROC works. So the ROC is a specific call for the AMD GPUs. Do you want to stick to programming streams or anything? I'm going to answer that question in a second. Maybe not. It depends on who you want to raid. So hopefully I can make one for Intel graphics. I would prefer someone who does like, either programming or something educational. Just cool people who are also trying to, do something interesting. And specifically, if there's like another researcher who's like doing new, like, computer science or biology or physics research, that'd be quite cool. Anything like that would be nice. So, yeah, hopefully I can make one for Intel graphics. Oh, that would be interesting. I don't exactly know how that would work. Yeah, I don't know how that would work. But if you could find a way to dispatch onto that would be super cool. Honestly, like, way above my level in understanding how this stuff works, So... Okay, right. Yeah, that's the other thing. If you wanted to test this out, you'd have to test it out specifically on a CUDA GPU. It might also have the problem on an AMD GPU, but I can't verify that. And also, in case anybody's wondering, I did try just a CUDA kernel that does the same thing. The CUDA kernel works just fine. So here, I'll show that as well. Let's go into vitest3.jl. So here's a CUDA kernel that just does seal, which is the same. It's like the sealing. I did something weird here trying to check. Yeah, but anyway, the point is I've done that as well. I've tried just a CUDA kernel just to see if that would do it. But yeah, it didn't really do anything. Okay, so I'm going to go ahead and raid Anthony Writes Code, and we'll go from there. Writes Code. Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I'll see you guys next time for the next episode of Simuleos. It'll be tomorrow. I don't know how long I'll go, but we might also be tackling this problem as well. I don't know. I'm just lost on it, and I'm so sorry about that. But thanks guys again, and I'll see you next time. Bye guys.